Hi friends, this is Yaganti Ishwaradu from cfamily.com. In today's session, we are going to discuss about introduction to Pandas. So what is Pandas, where we are going to use Pandas, so what kind of data structures we are going to use in Pandas. If you observe data science and data analytics, so there we are going to get large data sets like we are going to get the data sets in form of CSV files or Excel files or different data sets we are going to get. The main intention is by using those data set, we need to analyze those large set of data points to get answers related to that data set. For example, I have some diabetes data set or heart disease data set or cancer disease data set or some bank data set or some financial or stock market data set. I have large number of data sets. From those data sets, for example, if I have some stock market data. From that stock market data, I wanted to analyze the next day stock market price. So what will be the next day's stock market, or what is the stock prices in last 6 months or 1 year or last quarter? Means in order to analyze those questions, so we are going to use these larger set of data sets. But pandas here, why we are going to use pandas is one of the predefined module provided by Python and which will makes data science very easy and effective. How it will makes easy means one of the important data structure in pandas is data frame. One of the important data structure in data pandas is data frame and series. There are two data structures. Mostly we are going to use in machine learning concept or wherever analytics is required, we are going to use data frame. Data frame is a like two-dimensional structure two-dimensional structure which is having rows and columns which is having rows and columns so which is similar like table like structure but lot of powerful operations like lot of statistical operations we can do that in a data frame: mean, median, mode, standard deviation, and some of the useful functions like min, max, count, and so on. We can do a lot of mathematical operations and data frame as well as, so by using this data frame, we can do time series analysis also. Time series analysis. In the later sessions, we are going to discuss all these concepts, how to do time series analysis, how to find mean, median, mode, standard deviation, min, max, count, and so on. A lot of operations we can do on a data frame, not only for selecting the values like table, but we can do a lot of operations on the data. And series is one-dimensional data structure. One-dimensional data structure. If there is a need for one-dimensional data, then I can go for series. But mostly in our machine learning algorithms, we are going to use data frame. And one important point of this Pandas is completely open source. Open source. If you are using Jupyter Notebook, by default you are going to get this Pandas. By default you are going to get this Pandas. If you are using either IDLE or PyCharm or any other editor, if you are using IDLE Python provided software, so then you need to install like pip install pandas. So for example, open command prompt. I have created one folder called as the pandas examples. Open command prompt, the pip install pandas. So I have created one folder pandas examples means so all my programs I will save in this pandas examples. But if you use pip install, it will install globally. You can use this pandas package anyway. See here, click on enter. If you see here in my system already it is there. That's why it is giving a requirement already satisfied. But if it is not there in your system means it will install the required functions. Once if you install Python, it is very simple. By using pip command, you can install pip install pandas. It will install pandas in your system. Later, wherever it is required, I can import that pandas. I can import by using like import pandas. Wherever it is required, import pandas as PD. So as PD means I am renaming pandas as PD. Later, wherever it is required, I can use PD. So there are a lot of functions are available. So pd.dataFrame, which will create a data frame, pd.series, which will create series. And like this, a lot of predefined functions are available. We can use these pandas to create the required data frame and series. And this Python with pandas, it is lot of domains it is using. Python with pandas, Python with pandas. It can be used in wide range of fields, including academics, finance, finance, economics, economics, statistics, analytics, statistics, analytics, analytics, and lot more than these domains you can use in healthcare, or you can use in educational institutions, that is academics. You can use anywhere. Wherever some analysis is required, we can easily construct this data frame. We can easily perform the operations and data frame. We can see those operations in the later sessions. Remember, Pandas is providing two kinds of data structures, that is data frame and series. Data frame is two-dimensional and series is one-dimensional. So key features I can list here. Key features about Pandas. It is fast and it is fast and efficient data frame. It is having fast and efficient data frame object. And one important feature is, if you go with the table, so just if I declare, means in other programming languages or other language other than this Pandas, if I use table is nothing but rows and columns. Something column one, name, age, something like this. So by default, how it will store means with the default indexes starting from 0. Name is something, age is 25, and male, something like 1, so 24, female, and so on. If you go with default table, it is having default indexes like 0, 1, 2, and so on. But I can customize these indexes. I can customize these indexes in Pandas data frame, that we can see in the later sessions with practically how to customize these indexes. So what is the advantage means, for example, I am having some time series data. I can keep the indexes time so that I can analyze based on the time. Some coffee shop is there. He is selling some coffee related products, coffee, brew, and so on. Brew and so on. For example, day 1. If I use default indexes like 0, so brew, product is brew, something quantity sale is some 10, and coffee or tea, quantity sale is 25 on the, so 20 May 2020, and something index 1, so brew, it is he sold some 15. So tea something he sold 20, is 21st 5 2020. If I have like this data for 1 year or 1 month data, he can plan for the future data. But if I use these indexes, default indexes, it is not possible to analyze, means month wise or day wise, or so it is somewhat difficult if I need to analyze with these default indexes. Instead of this, if I keep this day or month as an index, instead of this, if I place this day or month as index, it is easy to analyze the data. This customization of indexes, it is possible in Pandas. Customization of data is possible in Pandas. Customization of index. So in the later sessions, I will show you how to place this customization indexes in Pandas in data frame. So this is one of the important feature, and also it is having techniques to handle the missing data. Handle missing data. Why to handle missing data means most of the machine learning algorithms, not only most, every machine learning algorithm, it will depend on data. It will depend on data. If the data is missing, for example, this is my data. So something my data is like this. If some values are something like salary, experience, some other details are there. If some values are missing, if I wanted to predict some future data, it will give inappropriate results. Means first I need to fill the missing values. In order to fill the missing values, Pandas is providing lot of techniques. We can see all those techniques. And if I create a table, it is very difficult to delete the column, but Pandas is providing. We can easily delete as well as we can easily add the columns. Add the columns to the data frame. We can easily create columns. We can easily delete the columns in Pandas. And one more important functionality, as I told, so this concept we are going to call it as time series analysis. So whatever we are going to keep time as index, I can analyze month wise, day wise, or year wise, quarter wise. So this concept we are going to call it as time series. Pandas is providing effective time series analysis. In the later part of later sessions, we are going to check all these concepts. So thank you, friends. This is about introduction about Pandas. In the later session, directly we will start with the time means series, data frame, how to analyze the data by using series and data. So thank you, friends. In the next session, we will meet with some other topic. In today's session, we are going to discuss about one of the important data structure in Pandas. So that is series. So what is series? A series is one dimensional, one dimensional, one dimensional labeled homogeneous array, labeled homogeneous array, and its size is immutable. Its size is immutable. Size is immutable, and values are mutable. Values are mutable. So what is immutable? Mutable means already we know what is mutable, and immutable means we can able to modify. We can able to modify. But immutable means once if the series size is created, it cannot be modifiable. So that's why the size is immutable and values are mutable. Values we can change, values of series, but the size of series is immutable. Val size cannot be modifiable. Cannot be modifiable. So that is mutable and immutable property. In today's session, we are going to see how to create a series, how to create a series, and how to create custom indexes, custom indexes. This is one of the important feature in Pandas. As usual, if you see in any Python array or any arrays, so by default it will create an index. But here we can create our own custom indexes in series. And then how to access series elements. How to access series elements. So these are the topics for today's session. First, we will start how to create a series. In order to create a series, the syntax looks like this. Syntax of series. First, we need to import pandas. Import pandas. In pandas, so there is one structure called as series. Pandas dot series. The syntax is data. So for which data you wanted to create a series, and index. So this is one of the important attribute. We can create custom indexes, and data type. So if you wanted to specify particular data type, you can specify the data type in. The first attribute is data. The data takes here we can create a series like which will takes values from forms like list, list, nd array, or constants. We can pass any of these to create a series. And then index, as I told, we can create custom unique indexes. Values must be unique. So while creating index, there is a rule that values must be unique. Values must be unique. And same as length of the data. For example, if I have 10 values in series, so the indexes you need to give is 10. Same as length of the data. Length of the data. By default, it is. I will show you what is by default, how the index will be like this. By default, it is numpy dot arange function of n. By default, it will be start from 0 and length of data minus 1. A series can be created. One note here. Series can be created. Series can be created by array, list, scalar, dictionary, and so on. We can use all Python related data structures to create this series. Now, first step. So create an empty series. So just if I wanted to create an empty series, create an empty series. So a basic series which can we create is an empty series. So by a basic series, which we can create is an empty series. An empty series. So just create like this. Import pandas as pd. Import pandas as pd. As pd means it will rename pandas with another name called as pd. Now instead of using full name, I can use pd dot series. So if I don't pass any data, so by default it will create an empty series. So go to Jupyter Notebook. So what I will done here is I have created one folder called as pandas examples, and in this type cmd which will open command prompt with that folder. After that, type Jupyter space notebook, Jupyter space notebook, which will open the Jupyter notebook where we are going to write the program. Click on new, click on Python 3. So first, in order to work with pandas, first we need to import pandas. Import pandas as PD. So some series S equal to PD dot series. I wanted to create an empty series. Print yes. See here, nothing is created. It is an empty series. It is an empty series. And now create a series from ND array. Create a series from ND array. Second way of create a series from ND array. ND array means n dimensional array. N dimensional. So see here, I am having ND array created from numpy, an array A equal to np dot. So there is a method called as array method to create an array. So I am creating some one dimensional array. 1, 2, 3, 4, and 5. Some values I am giving in this array. Np dot array. From this I can create a series S1 equal to PD dot series of A. Then it will create a series for that array. Print S1. We'll copy these statements. So go to Jupyter Notebook. So paste here. See here how the array series will be created and what are the indexes by default. Execute this. Here, in order to use numpy, first you need to import numpy. Import numpy as np. So then you can use this numpy. See here, so these are the indexes. So these are the values what I have given 1, 2, 3, 4, 5. So these are the indexes. If I don't give the index, by default it will start from 0. So by default it will start from 0, and it will be incremented until length of data minus 1. Means length of the values, it is 5 values. So length of data is 5. 5 minus 1 is 4. So it will start from 0 and it will increment up to the length of data minus 1, that is 4. By default, it will display the index starting from 0 and the length of data minus 1. Now, I wanted to define custom indexes. So defining custom indexes. Next, defining custom indexes. Defining custom indexes. So there is one attribute called as index is there. So for that we are going to pass the indexes. For example, go to Jupyter Notebook. I will declare one array. So data equal to np dot array. If I wanted to use a numpy, first import numpy as np. If you use the same session, no need to import again. But if you open again new Jupyter Notebook, there you need to means import this numpy or pandas. If you use the same session, again no need to write. But if you use a different notebook, then you need to import pandas and numpy. Import pandas as PD. Now np dot array. So I'm defining some strings like Ishwar and one more name and Rakesh. So I'm defining some strings in this array. So if you wanted to print this array, print data. So it is array. So now for this array, I wanted to create a series. So without giving index, first I will show you. And after giving customized index, we will check. So S2 equal to ed dot series of data. To execute this, print S2. You can see default indexes 0, 1, and 2. But I wanted to mention the student IDs like Ishwar 101, 102, and 103. I wanted to give their IDs. See this? So I will copy the same code, paste in this cell. Here, one attribute called as index. So there I can pass the custom indexes. So comma index equal to, for example, 101, 102, 103. So what is the difference between normal array and this index? So here we need to give the index in series, not in array. So copy this, paste here, execute this. Now you can observe the difference between normal array and this series. We can customize these indexes by using this index attribute. If I use the normal array, so just whatever the default indexes it will generate, we need to use those indexes. But here we can define our own custom indexes in series. And so I will show one more example. Create a series from dictionary. Creating a series from dictionary. Next, creating series from dictionary. Series from dictionary. Series from dictionary. How to create a series from dictionary? So see here. So I will define a dictionary is nothing but key value pair. Already we know dictionary is nothing but key value pair. Key value pair is a dictionary. A dictionary can be passed as an input to this series, which will create series. But here observe. So first I will give one dictionary. So just I will take one example dictionary. I'm having A and its key is 1, value is 1. In dictionary, the syntax is like this: key value pair. Dictionary we are going to display within braces, key and corresponding value, comma, key 2, comma, value 2, colon, value 2, key 3, value 3. So like this, we are going to display key value pair in dictionary. So like that, for example, key is A, value is 1, key is B, value is 2, key is C, value is 3. The key value is separated by colon and key value pair is separated by comma. So I'm having three pairs. For this, I will give some series S3 equal to ed dot series. I will pass this data to dictionary. We will see the output, what it will happen here. I will copy this data, execute this, execute the output, then you can find what is the difference between normal array passing to the series and passing dictionary to this series. Execute this. If you see here, by default, indexes are taken as these keys. Means A is one index and B is another index, C is another index. There are three values, three keys are taken as indexes for this series. If I create a series from the dictionary, by default, it will take series key values as series, means a dictionary key values as series indexes. And I can also pass the indexes, means like previous example we saw, right? So I can also pass the indexes like this. Instead of taking all these indexes, I can define custom indexes or I can use the same index. See here, I will copy the same here. See, there is one attribute called as index. For this index, I will pass some indexes like B, C, comma, D, comma, A. See here, actually, I have only three values A, B, C, but I am passing four indexes B, C, D, E. So if I give the values like this, actually, I'm not giving A, B, C, D, I'm giving some random order. So B, C, D, E. Execute this, observe the output here, observe the output here. So index, comma, index equal to this, execute this. If you see here, whatever the order of the indexes I have given in the same order, it is printing. So B is 2, C is 3, but the D value, it is not there. So actually in my dictionary, so D key is not there. If it is not there, so what it will print? It will print NaN. NaN means not a number. If the key is not present in this index, whatever the index value here, if it is not present in the index, then it will print NaN in the output. So here the index I mentioned D, but this D key is not there in this dictionary, then it will take NaN. Like this, for example, if I take one more index E, for E also it will print NaN. So like this. And so this is the way how to create a series by using dictionary. And one more, if I give less, here I am giving more. If I give less indexes here, what it will happen? I will give only B and C. Execute this, execute this. So then see here, it is printing only two because I am taking only two indexes, even it is having three values. I am giving only two indexes. These two indexes values are printing. But if I give more than the key value pair, then it will print NaN. Next, create a series from scalar. Create a series from scalar. Create, create a series from scalar. Create a series from scalar is nothing but value. The value. Scalar is nothing but value. Now see here, import pandas as PD. Import pandas as PD. So see this example S equal to PD dot series series. I am taking some scalar value. Scalar is nothing but value. So I am taking 5, but indexes I am giving like this. Index equal to 1, 2, 3, 4, 5. So then what value will print at this index? The question is what value it will print at this index? What value it will print means it will print the 5 in those indexes. See here, I will execute this. Execute this. Here I am giving 5 indexes, but I am taking only one value, that is scalar 5. Execute this. PD import pandas as PD 5 comma. Here one more brace extra is given. So see here, I have taken a scalar 5. In these indexes, it is printing. If I give only one scalar value, how many indexes I am going to give? In those indexes, it will repeat the same value. Now we will see how to access these series elements. Accessing series data with position. Accessing series data with position. How to access? Means already I have created a series. How to access these series values? So first I will create one series here. S1 equal to PD dot series. So directly I will create it from a list 1, 2, 3, 4, 5. 5 values. I will give 5 indexes. Index equal to You can give your own index. If I wanted to give some custom index, I can give my own index. For example, I am giving A, some alphabet name, B, C, D. There are 5 values. I will use only 5 indexes, 5 values, 5 indexes. Print S1. See here, 1, 2, 3, 4, 5. I have taken 5 indexes A, B, C, D, E. It is printing A, B, C, D, E and their corresponding series values. Now, if I wanted to access first element, how to access? So see here, I will try with S1 of 0, whether it will retrieve with a 0 index. Try to execute this. My series name is S1. Just I wanted to test whether by using the indexes it will return the value or not. Execute this. Awesome. It is returning the values with indexes like an array. So by default, it is starting from an index 0. I can access by using their indexes. If I wanted to retrieve multiple elements within those list, means within those index, multiple elements, multiple elements. I can give the range like S1. I wanted to print 1 to 4. It will exclude the last index means 1, 2, 3 only it will print. Execute this. Awesome. Here also it is printing BCD means second index, third index, and fourth index. It is printing these values. Okay. And now retrieve if I don't give any start index like an array. If you remember our NumPy arrays or Python arrays, if I don't give start index, just I wanted to give the end index. What it will do here is it will print from start index 0 up to this end index. So by default, it will start from 0. So 0 index, next 1 index, 2 index, and third index. So if I give 3, it will exclude 3, means it will print only ABC. If I don't give end index, yes, 1, so just I will give 1. I don't give any end index. So it will print all the remaining elements from the first index. And next, retrieve the elements. Retrieve the elements. One is series of index. So then I can access by using an index. Next, retrieve data of series, data of series by using labels, labels, by using labels. So what it means? For example, labels are nothing but indexes. I can access with their default index that is 0, 1, 2, 3. It is starting from 0. That's what we saw in the previous example by using so default indexes. Now, if you see our output, it is having some custom indexes B, C, D, E. Whether I'm able to access with these indexes. The question is whether I can access these custom indexes. So see here, so I wanted to access A value. So custom index A value. Execute this. My series name is S1, right? I need to give S1. Execute this. Yes. With the custom indexes also, I can able to access. S1 of B. Execute this. S1 of C. So with the custom indexes also, I'm able to access. So this is retrieve series data by using a label. And if I wanted to access multiple values instead of single A, B, or C indexes, I wanted to access multiple index values, means A, B, C values I wanted to access. S1, my series name is S1. See here, I need to define the list like this A, B, C. I wanted to access 3 values A, B, C. Execute this. So see here, I am able to access multiple values by using this custom indexes. For example, in my series, first print S1, it is having E, but I wanted to access the index which is not there here. S1, the index which is not there here. Execute this. You can get definitely you can get an error. Key is not found. Because this key is not there here, it will return key not found error. Like that, we can access with the default indexes. We can access the series elements with the custom indexes. For example, S1 of 0, execute. So this is default indexes and our custom indexes S1 of, execute this. We are able to retrieve the series data by using custom indexes and by using default indexes. So that's it, friends, today's session. And in the next session, we will discuss some other topic. In today's session, we are going to discuss about data frame. What is a data frame? How to create a data frame from different Python collections. We will see. A data frame is nothing but a data frame is a two-dimensional data structure. In Pandas, a two-dimensional data structure is a data. Nothing but a data is aligned as tabular fashion, tabular fashion like rows and columns. But there are a lot of advantages when compared with the table, but we will get a lot of advantages. We can set custom indexes. We will discuss later in practical how to set custom indexes, but it is like table structure, but lot of advantages when compared with data frame. Some features of data frames are like this. Features of data frame. Columns are of different types. Potentially, columns are of different data types. Potentially, columns are of different data types. So it is not like that if I use integer, all the columns should be integer. If I use float, it should be float or something. It is not fixed like that. You can use any type of column in data. Potentially, columns are of different data types. And size is mutable. Size is mutable. Nothing but I can add the columns, I can remove the columns, I can remove the rows, I can add the rows. We can do lot of modifications in data frame. So that's why data frame is a mutable data type. Modifications are allowed. Modifications are allowed. And labeled access. Labeled access. So what it means we can change, we can set our own indexes for the rows and columns. Predefined indexes will be there, but we can change the indexes for the rows and columns also. And last, one more important point is we can perform arithmetic operations. We can perform arithmetic operations, arithmetic operations on rows and columns. On rows and we can perform arithmetic operations on rows and columns. The syntax will be like this. Syntax will be like this for a data frame. Pandas dot data frame data index columns and data type. So data is nothing but here I can give the data in any format, like I can provide the data in the format of list. or I can provide the data in the form of series, or I can provide the data in the form of ND array. ND array, it is a NumPy n-dimensional array, ND array, a dictionary or constants or any other format. Dictionary or constants or any other data frame. I can also give input as a data frame to create another data frame. And the index, it is index of the table. By default, it will be np dot a range of n, nothing but it will take the length of the number of rows and it will generate the index from starting from 0 and it will generate up to n minus 1 indexes. If I give a range of n means it will exclude this last index value. It will generate up to the index starting from 0 to n minus 1. By default, it is n minus 1. I can set custom indexes in data frame. And columns. So these are the column names. If I don't mention any column names, by default, it is np dot a range of n. So that means it will generate 0 to n minus 1 indexes for column. And data type. So finally, it is D type. So D type, nothing but data type. D type is data type of the column, data type of columns. And now we will see how to create a data frame. Creating data frame. So I can use, to create a data frame, I can use list or I can use ND array. As I told while discussing definition, list, ND array, or dictionary I can use, or I can use other data frame, or I can use series and so on, other data frame or series. So first we will see an example creating an empty data frame. How to create an empty data frame, and I will show you how to create a data frame from list. First open our Jupyter notebook. I have created one folder, Pandas example, type CMD, type Jupyter space notebook. In order to work with Pandas, first click on this new, click on Python 3. In order to work with Pandas, first I need to import Pandas. Import Pandas as PD. First creating an empty data frame. Creating an empty data frame. See here, PD dot. So PD is nothing but Pandas dot data frame. Pandas dot data frame. Just use this method. It will create a data frame. Print df. You can see an empty data frame. So nothing is created. Just I am using PD dot data frame. It is creating an empty data frame. And next, creating a data frame from list. Creating a data frame from list. I will declare some Python list. You know how to create Python list. A list can be created by using square brackets, and each value inside square bracket is separated with comma. Something I have list values 1, 2, 3, 4, 5, 6, and so on. These are my list values. In Python, list is nothing but which we need to declare within square brackets, and each value is separated with comma. And creating a data frame, df equal to pd dot data frame. Now for data, I need to mention list. So my list I need to mention print df. As I told, if I don't give any index, by default it will start from 0. That is range minus 1. It will take its own indexes, means it will take np dot a range. So totally 6 rows are there. It will start from 0. It will print up to n minus 1, that is 5. By default, it will take the indexes as np dot a range of n. Next, creating a data frame from dictionary. Creating a data frame from dictionary. How to create a data frame from dictionary? As we know, in Python, a data frame is nothing but key value pair. A data frame is nothing but key value pair. So I have the information like students info, students info. A dictionary is created with braces, and in braces, I need to declare key value pair, something all the names of the student. So this is a key, and values are like this: list of students, Rakesh, and then Ishwar and Srinivas, and so on. Let there are three students are there. So this is one key value pair, and also I have their ages. So age is one more key. There are three students, 24, 25, and 26. Some ages, and also I can declare if I want one more key, and I need to separate with comma and declare here one more key. So that is marks something 95, 94, and 96. So this is my dictionary. If you wanted to print student info from this dictionary, I wanted to make a data frame. This is my student info. See here. So df equal to td dot data frame. So data, I wanted to give this student info as data. Student info as data. Print data frame. So what is the difference you are observing here is previously if I don't give column name, by default it is starting from 0. If you see dictionary, what it is doing here is the column names it is taking from keys. Means name is a key, it is taking one column. And age is key, it is taking one column. And marks is another key, it is taking another column. And values, so whatever the values for that key, Rakesh, Ishwar, and Srinivas, and their ages 24, 25, 26, and marks are this. Means each key and the values are corresponding to rows. So this is creating a data frame from dictionary. And creating a list means creating a data frame list of list. See here. So next one is creating a data frame from list of list. List of list. See here, I have some data like this. So list means square brackets. Again, list consists of another list. Something Ishwar and his age, and one more list Rakesh and some his age, and one more list Srinivas and his age 20. So this is my list of list. So this is one list. Again, list contains another list like names and their ages. So how to create a data frame by using this list of list? Same method. So data frame, instead of df means it will override old df. I will use some df1 equal to td dot data frame of, here data d is capital and frame f is capital, and there is no space. Data frame single word, because it is completely case sensitive. We need to follow these rules. It is a predefined method. So D is capital and F is another capital. So this is defined in Pandas package. Create a data frame. Now data is this list of list of list. First, don't give anything. Execute df1, whether it is creating or not, we will check. So what it is doing is, default it is taking some indexes 0, comma 1. The column names I didn't mention anything. It is taking default a range of n. So there are three values. So it will create 0, comma 1. There are two values only, right? Means the name and ages. So it will create 0 and 1. Now, if I wanted to give column names, custom column names, copy this and execute here. I wanted to give the custom column names, means it is a name and it is yes. I wanted to give the custom column names. See here, there is one attribute called as columns. In this columns, I wanted to give first column name is name and second column is yes. Second column is yes. So print df1. See here the difference. Previously, if I don't give the column names, it is taking some default values starting from 0. And if I can mention the specific column names, name and yes, it will display the column name as name and yes. And next, creating a data frame from list of dictionaries. Creating a data frame from list of dictionaries. Data frame from list of dictionaries. Dictionary. List of dictionaries. See here. So my data is like this. List means square brackets. In square brackets, I wanted to declare something dictionary like this. A1 and something B2. So this is one dictionary. And another dictionary is like this. A5 and B6 and C7. So something list of dictionaries. The first dictionary contains two key value pairs and second dictionary contains three key value pair. Now I can create a data frame like this. See here, df2 equal to td dot data frame of. So directly I will give this data as input, execute this. So what you are getting, the output we can expect. See here, the keys it is taking as column names. If you see second dictionary, it is having three keys. That's why it is giving three column names A, B, C. But if you see the first dictionary, it is having only two columns A and B. The A and B it is filling 1 and 2. But C it is not there right in the first dictionary. If any value is not present in the key, it will replace with NaN, not a number, not a number, not a number operator. If any value is missing, it will replace with not a number operator. So this is creating a list from dictionary, and I wanted to change, I wanted to change here it is displaying some default values. 0 and 1 for indices, 0 and 1, but I wanted to display it as a first row and second row. So I wanted to give some custom name. How to give the custom indexes? See here. So df2 equal to pd dot data frame, and data is same. If I give only data, it is creating some default indexes 0, 1. Sequentially, it is creating indexes. But I wanted to create my own index. There is one attribute called as index attribute. I need to mention number of rows. The first row, I wanted to give the custom name first. And second row, I wanted to give the custom index second. Execute this. You can observe the difference between previous output and this output. In the previous output, by default, it is giving 0 and 1. Now, custom indexes I am creating by using this index attribute. Next, we will see create a data frame from dictionary of series. Create a data frame. Create a data frame from dictionary of series. Dictionary of series. First, we will create the data. Later, I need to pass that data to this data frame method. Example, dictionary of series, I'm declaring as a D. In Pandas, we are having pd.series, which is used to create the series. So first, dictionary, first key I'm giving 1. In this key, I'm creating a series, pd.series. S is capital, series. If you remember our first means previous classes, you know how to create a series. So I'm creating this series from list 1, 2, 3. So this is first key value pair and second key value pair. See here, second key value pair pd dot series. For this also I'm giving some list 1, 2, 3, 4. 1, 2, 3, and 4. So this is my data. For this, I wanted to create a data frame. df equal to pd dot data frame of d. So give this. So without giving index and with giving an index, we will see. Execute this. Print data frame. You can see this key value is taken as a column names, but here it is giving some default indexes. I don't want default index. I wanted to create custom index. I wanted to create a custom index here. So while creating a series itself, I can give index equal to, there are 3 values, something I wanted to give A, B, and C. A, B, and C. And this second series also I wanted to mention the custom indices, index equal to, there are 4 values, I will give 4 indexes, B, C, and D. So there are 4 indexes. Now execute again. See here, instead of 0, 1, 2, 3, 4, it is giving now, it is giving A, B, C, D. We can define our own custom indexes, which is not possible in our normal tables. But here, we can apply our own custom indexes for rows and columns. How to select particular column? If you see here, I wanted to select only this particular column. So my data frame is df. So my column name is 1. Execute this. You can able to select only one column. I wanted to select second column, but you need to, while giving the names, don't misspelled it, or you need to use the same case. See here, this is second column. I wanted to access only second column. Execute this. It will access only second column. And how to add some column. This is already existing DFF, means in my data frame it is having 1 and 2 columns. I wanted to add third column. How to add third column? Just my data frame is DEF. I wanted to add third column, DF of 3. I wanted to add third column. For this column, I wanted to add some series, pd.series, pd.series, 10, 20, 30, and index equal to something A, B, and C. So this is DF of 3. Now print to DF. You can find third column is added. Directly for that data frame, give the column name, and here you can create with a list or set or dictionary, or so whatever other data frame you can create this column. After creating, so you can find that added column in the data. So this is column addition in data frame. Column addition in data frame. This is column addition in data frame. Column addition in data frame. Similarly, if I wanted to select particular rows, I wanted to select particular rows, data frame. I wanted to select second and third row. I can use slicing operation, means start index and end index. See here, data frame of start index colon end index, up to which index you wanted to retrieve. From which index I wanted to start and up to which index I wanted to end. See here, I am telling I will require second and third rows. If I give like this, whether it will print third row or not? No, because because it will exclude. So 2 comma 3 means what it will do means, for example, I need second row, right? Means -1 means it is starting from 0. If I need second row means it is 1. So 1 and 2. See here, it is printing only second row. It will exclude end index, means this end index will be excluded. If I give 1 colon 2 means 2 minus 1, it will print only one row. That is second index row. If I need second row also, here I need to give 3. What it will do means, it will print third index. So second and third rows. If I need fourth row also, here I need to give 4. Then it will print up to, so 3 index means our index normally it will start from 0. Fourth row nothing but 3. It will exclude last index while retrieving the rows. And then it is slicing of the rows. How to add the rows to our, how to add rows to our data frame. So adding rows to our data frame. See here, I have two data frames here. So data frame equal to pd dot data frame, pd dot data frame. One data frame is like this. I'm having list of list 1 comma 2 and 3 comma 4. So there are two list of values, and column names I wanted to define my own column names. First column name I wanted to give A, and second column name I wanted to give it as B. So this is one data frame. Similarly, I will copy and I will create one more data frame. So df1 equal to, in order to don't confuse, I will change these values 5, 6, and 7. So this is second data frame. How to merge these two data frames? I wanted to store all the values in this data frame. Otherwise, what I will do, first I will print df1 and df, print df1 and df. So print, see here, data frame. Yes, spelling mistake. Here it will be, we need to give the same name. So this is data frame 1 and this is second data. Now what I want to do is, I wanted to merge these two data frames. Finally, I wanted to create a single data frame df. See here, df equal to original data frame dot, there is a method called as append method. For that append method, I need to give the second data frame as input. Now print df. You can see all the values merged as single data frame. All the values merged as single data frame. Now, how to delete the rows? How to delete the rows? Or first we will see deleting columns. So this is my data frame. What I will do here is, I will take this, means I will show you. I will execute this data frame and I will add third data frame, means third column. Now you can find the data frame is this. The data frame is this 1, 2nd, and 3. I wanted to remove this third column. So I have added third column. Now I wanted to remove this third column. So there is a method called as, there are two ways. One is by using del keyword, I can remove. Or one more thing is by using pop method. So first we will see del method. Del, so df of 3, df of 3. Now print df. You can find, so 3 got removed. Like this, I can drop df dot drop of second column. I wanted to drop second column. Execute this. Df dot drop of second not found in access. See here, second SCCOND. So here it is pop to remove the column. The pop of second. See here, it removed this second column. Now only one column is there. Now only one column is there. So what is the advantage of this pop is, after removing it will return the particular column which got removed. If you see here, second column having 1, 2, 3, 4 values and these indexes are A, B, C, D. It will print which column got removed by using pop method. By using del method, just it will remove that column. And if I wanted to check, again I need to print. So what got removed, or I will print data frame so that I can understand which got removed. But in pop method, directly it will print which column it got removed. So finally, for today's session, so deletion of rows, how to delete a row, deletion of rows, deletion of rows. Here for deletion of rows, we can use drop method. Previously here I used a drop method, but for deletion of rows, we need to use drop method. Df dot drop of zero index I wanted to drop. Zero index I wanted to drop. So give 0. Execute this. Here we change the index, right? I need to give this index is A. If I don't add custom index, I can give 0. Now we can see first row got removed. In our new data frame, it is from B, C, D. So first row got removed. Like that, if I wanted to remove B row, execute this, it contains only, means why it is not happening in the original data frame is, if I wanted to get effect in the original data frame, I need to use one attribute in place equal to true. What it will do means after removing, it will place the changed contents in the data frame. If you see here, even I removed A and B, if I print here, if I don't use in place equal to true, it will print 4 values. But if I use this attribute in place equal to true, execute this and execute this. After executing A and B, now I have data frame is only C and D. Now print df contains, I think this value is not executed. Execute this. Oh, here I didn't use in place, right? That's why it is showing that in place equal to true. Execute this. Now you can find data frame only 2 values. If you use in frame, it will affect the changes in original data frame. If I don't use in place, it at that time it will remove that value, but it originally it won't remove. It will keep that value. Again, if I print, it will show that total car. If the fx has to be changed, means I need to use the attribute in place equal to true. In this session, so this is the last topic. We will meet with some other topic in the next session. In today's session, we are going to discuss about reading CSV file by using Pandas. How to read a CSV file by using Pandas is, so there is one method, read underscore CSV, which is used to read a CSV file in Pandas. First, I need to import Pandas. Import Pandas as PD. So PD is nothing but renaming Pandas. After reading, after importing Pandas, so we can read it by using read underscore CSV method. For this method, the attribute we need to provide is the file name. File name. So which file, which CSV file you are going to read, you need to give that file path. So then it will create a data frame for this. It will create a data frame. And I will show you the different operations what we can perform on the data frame. So open Jupyter Notebook. So I have created one folder, Pandas examples. In that I'm typing CMD, it will open directly that folder in command prompt. Type Jupyter space notebook to open the notebook. Type Jupyter space notebook. Jupyter space notebook. It will open the Jupyter notebook. Here type new Python 3. It will open the cells where we are going to write the programs. First, you need to import Pandas as PD. So PD is nothing but renaming that Pandas as PD. Now, in Pandas, there is a method called as read underscore CSV. So mention the file path. So I will use some CSV file which is available with me. It will create a data frame. It will create a data frame. Here I am using read underscore CSV method to read a CSV file. I have one CSV file in this path. I will take that CSV file. Mention that file name here. In this path, I have one CSV file, ign.csv, ign.csv file. You can take any CSV file. The process is same. I will show you what are the different operations we can perform on CSV file. Once if you read, it will construct a data frame. A data frame already we discussed in the previous sessions. A data frame is nothing but two-dimensional data structure which is having rows and columns. See here, to display DF, here it will display rows and columns. It is a like table-like structure. It is like table-like structure. Next, after reading a data frame, how to see the shape of the data frame? So to see the shape of the data frame, there is one attribute, shape attribute, which will display the shape of the data frame. Go to Jupyter Notebook, df.shape. See here, there are 1001 rows and 8 columns. So to know the shape of the data frame, shape attribute, and this shape attribute only I can separate. Sometimes I need only rows, sometimes I need only columns. So how to separate this? See here, rows comma columns equal to df.shape print rows and print columns. Execute this. Columns, spelling mistake, whatever the columns we have, same name we need to give here. Execute this. So 1001 rows and 8 columns. Once after constructing a data frame, if I wanted to see only top 5 rows, so there is one special function is there. So head function in pandas, which will display top 5 records. Top 5 records. See here, my data frame is df dot head method. Execute this. You can find top 5 rows. Top 5 rows. And if I want only top 1 row, so df dot head method. If I wanted to read only top 1 row, give 1. It will display only top 1 record. If I wanted to display top 3 records, so head of 3, it will display top 3 records. Like this, there is one more option in Pandas. There is a tail method, which will display last 5 records. Last 5 records, which will display last 5 records. See here, df dot tail method. Execute this. You can see last 5 records in data frame. Like that, if I wanted to display only last record, so I can give tail of 1. It will display only last record. Now, so there is one more way how to access the records. These are giving head and tail. Either they are giving top records or last records. If I wanted to access some intermediate records, then we can do slicing operation. Slicing operation is nothing but, see here, the data frame and start index colon end index. Start index colon end index. Here I can specify start index where I need to get the records, where I need to start reading the records, and up to which record I want the details. So go to Jupyter Notebook again, df start index. For example, I wanted the records from 10 until some 25. So print this 10, 11, 12, 13, 14. If you see here 24. So what it will do in slicing is it will exclude the last index. It will exclude last index, exclude last index. Means if I give 25, it will print up to 24. If I need 25 also, then I need to give 26. See here, go and check. If I give it 26, then it will print up to 25th record. Now, I wanted to know what are the different columns present in this data frame. Here, if you see here in the screen, it is displaying some 5, 6 columns. Here, there may be lot of columns will be there. So, lot of columns may be present in the real-time data set. There may be hundreds of columns. How to know the columns in a data frame is one attribute df.columns df.columns, which will display all the columns which are present in this data set, data frame. The score, phase, title, URL, score, genre, release year, the release month, the release day, and it is object. So this df.columns which will display all the columns which are present in the data frame. And next use case, I need to retrieve. So first I will open this data set. See here. So this is my data set, score, phase, and title, URL, score, genre, release year, release month, and release date. So out of this, in the title, I wanted to retrieve some few titles. I wanted to retrieve only titles. So previously, if I give the data frame like this, data frame of some 2 to 10 means it is retrieving all the column values. But out of this, in the title, I wanted to retrieve some few titles. Some 2 to 4 titles I wanted to retrieve. Or 2 to 10 titles I wanted to retrieve. So then, so df dot, the column name is title. So be cautious while giving the names. Whatever the names in this, so data frame, same name, title, means case also it should match. If it is a capital letter, it should be capital letter because Python is completely case sensitive. So while giving the name, give the same name. If I give something capital also, it won't work. So whatever the title means, whatever the case is there, you have to give the same case. And in title, I wanted to retrieve some 2 to 10 titles. If I give here, it will exclude the 10th index. It will print up to 9 only. So execute this. You can see the 2 to 9 titles plus and NHL 13 and this. So this total war battles means up to 9th index it is retrieving. If I need 10th index also, here I need to give 11. So then it will retrieve up to 10th index. So this is retrieving particular column by using splice operation. And how to know the type of each column. Here if you see, so the different columns is there, score, phase, title, URL, score, genre, release year, release month. So different columns are there. I wanted to know what is the type of URL column. So there is a method called as type, and in the data frame for URL column, I wanted to know the type of URL column. The URL column type I wanted to know. So then shift execute. It is a series. It is series. It is series. And here I wanted to display previously, if you see here, df dot title of 2 to 10 or 2 to 5, something I wanted to print 2 to 5. It is printing only title. But if I wanted to print multiple columns with a slice operation, means I wanted to print a title as well as URL for that title and score of that title. I wanted to print these 3 columns by using slice operation. See here. So df is my data frame, and in this data frame, I need to use that list, means whatever the columns I want. One is score I want, and title I want. Title I wanted to retrieve, as well as I wanted to retrieve URL for that title. So like this, out of this title URL, I wanted to retrieve only 2 to 5 columns. So score, title, URL columns. Out of those also, I don't want all the records. Just I wanted to retrieve from 2 to 5 means 2, 3, 4 records I want. Execute this. You can see score of this title and URL of that title. So like this, if I give the list, only this list columns and with this specified rows, it will retrieve from the data frame. And similarly, so there are a lot of operations I can perform on this data frame. For example, if you see score is some integer column, I wanted to find what is the maximum score or what is the minimum score. See here, I wanted to find the maximum score. The next use case is from this table. So find what is the maximum score. What is the maximum score? See here, my data frame is df and score is my column. And in this column, I wanted to find the max value. The function I'm going to use is max function. Execute this. It will display the maximum value in that score column. And if I want a minimum score, df of score column dot min, which will retrieve minimum score in that column. And I wanted to find mean value of that score column. I wanted to find mean score of that column. That mean, which will retrieve mean score of that column. And all statistical operations, I wanted to find standard deviation of that score column. So there is one method called as std method, which will give standard deviation of that column. And I wanted to find mean, so mean is already over. So like this, so we can perform lot of operations on that columns. And there is one special function on the data frame, describe method. So df.describe method, describe method, df.describe method. Execute this. See here, it will give total count of the rows in that particular column, not null values. And also what is the mean, what is the standard deviation, what is the min, max value, 75%, 50%, and 25% of that column. For which columns it will display all this count, mean, standard deviation, min, 25%, and max values is for only integer or float columns. If I see here, the score contains floating values, a release year contains integer values, release month, and release date. Only for these columns it will provide output. Means if it is an integer and float columns, for those only it is able to calculate what is the mean, max, min, and all those values. STD 75%, 25%, and 50%. For a character, it is not possible. Means I cannot find what is the mean of this character column. Only it is applicable for float and integer columns. If you observe the output, it is giving output for score, release year, release month, and release date. And it is one of the basic parameter. Count is a basic parameter in machine learning. So based on this, what I can do means how many null values are present. For example, here it is showing 1001, 1001, 1001 in all the columns, but sometimes there will be some missing values in the Excel. For example, what I will do here is I will remove something. See here, just save this file, read again, read again, where I'm reading this CSV file. So go and read again. Execute that statement again. So df.describe, df.describe. See here, I have removed some columns, some rows values in release year. If you see here, release year, I removed some values. Nothing but null values, empty values in that column. What is the advantage of by using this count is while pre-processing data, first I need to analyze how many columns having null values. First I need to fill or remove those null value rows or fill, I need to fill those null value rows. Then I can process remaining process in machine learning. So this is one of the important measure in machine learning. So just I will undo this again. I will read. See here, I will read again. Now you can find 1001 rows in release here also. Execute this again. Execute again describe method. Now you can find 1001 errors. What is the advantage means? While pre-processing the data, if I wanted to know the null values, then I can use this count measure. So df.describe method, which is used to describe the complete data frame, and so which will describe for means float values and integer values. Next, if I wanted to select, this is my data frame df. Out of this, I don't want all the records. I want the records which is having maximum score, means greater than 9 or 9.5. I wanted to retrieve the records, means for example, if I wanted to go for some movie or some other place, first I wanted to score, means what is the score given to that movie. So based on that, means for example, if I take a rating for a movie, which is having out of 5 some 4.9 or 4.8, only those films I wanted to move. I have that data set. I can filter the records. I can go for the best movie. Like this, in this is a gaming data. For these games, I wanted to find which the games which are having more than 9.5 score. So df of score, which will retrieve all the score column, but I don't want all the records. The records which is having score is greater than 9.5. So the score is greater than 9.5. I wanted to find all those records. See here. So this is data frame. In this data frame, I need to find the records which is having the data frame of score greater than 9.5. Execute this. See here, if you see the score column, all the records having 9.6, 9.8, 9.7, 9.8, and so on 9. For example, I wanted to retrieve only 9 point greater than 9.7 records. I can filter. So based on my requirement, I can filter. Here I found only some 4 games which is having score greater than 9.8. And I can set index. There is one biggest advantage in data frame. There is one biggest advantage in data frame. We can set custom index. We can set custom index. Here, if you see here, by default, it is giving something 200 sequential. It is giving so starting from 0, and it is giving 1, 2, 3, 4 sequential. It is incrementing index. But I don't want the index some sequential numbers. I want the index as this title. Means based on the title only directly I will put an index. If I like some game, some XYZ game I like, I wanted to search only the details. I can set the index, custom index as title. Based on the title, I can search this data frame. How to set the index for the data frame is df dot, there is one method called as set index method, which is used to set the index for the data frame. For example, I wanted to set title as index, set index title. See here, there is one more attribute is there. First, I will execute this. Here, I am getting title as an index. Previously, if it is 0, 1, 2, 3, and so on, sequential values. Now, if you see the index, it is title. But execute again, whether it is really set as index as a title. See here, no. So why means directly it will not affect in data frame. If I want, it should be effect in a data frame. See here, one attribute is there, set index method. Title I wanted to keep it as a index, and there is one attribute in place equal to true, which will display the See here. So df dot title. So by default, it will change in data frame also. Print data frame now. It will replace title as a index. Wherever I will use, now I can use title as index. So this is about how to read a CSV file, what are the different operations I can perform on a CSV file. In the next session, we will see some other topics, friends. So we will meet at the next session. So thank you, friends. In today's session, we are going to discuss about how to write the data to CSV file. So first we need to create a data frame. After creating a data frame, so there is one method called as toCSV method from data frame, which is used to write the data to the CSV file. So first we will create one data frame. So open Jupyter Notebook. In order to open Jupyter Notebook, type CMD, type Jupyter space notebook. It will open the Jupyter Notebook. Click here, new. So first, if I wanted to work with pandas, first import pandas as PD. So PD is nothing but I'm renaming pandas to PD. And I need to create a data frame, PD dot. So there is one function called as data frame function in pandas. I'm creating a data frame by using dictionary. Like I have some students info names. I'm having different students names as a list, values as a list. Ishwar and Rakesh and Srinivas. So three members details I have, names, and each key value key value pair is separated with comma. I wanted to define one more key value pair, percentages, like something I have 95, 96, 94, and their ages 24, 25, and something 26. And also I have one more variable, grade, what grade they have got. So A plus. So these are characters, right? I need to give in a single quote, a double quote, A plus, and something I have some grades like this. Whatever the information you wanted to store, some student ID I wanted to store, student ID 101, 102, 103. So this is about my students info. By using pd.dataframe, it will create a data frame. I will assign it to one variable. So df student equal to pd.dataframe, which will create a data frame. If you wanted to see data frame, see here how it will create. It will create a table like structure. Here student. Here we need to give comma for each key value pair. See here, it is created a table like structure, names, percentages, ages, and grade and student ID. Now I wanted to write this entire data to a CSV file. I wanted to create a comma separated value. CSV file is nothing but comma separated value file. Comma separated value file. How to write is for this data frame. So there is one method dot to CSV. So I need to give the name of the file, something students CSV or students file, students info file, something I'm giving. See here, if I don't give the full path, If I give some full path like C colon something files colon slash something, if I give the full path, it will save in this path. If I don't give this full path, just if I give the name of the file, it will store in the current working directory. In the current working directory, I'm working here. So pandas examples, d colon pandas example. If you see here, there is no CSV file. Execute this, it will create one CSV file. Execute this and go and check that folder. See here, one file students info is created. If you see here, students info, which is a CSV file. If you see the properties, it is a CSV file. Here, if you see, all the values are separated with comma. 0, comma, Ishwar, comma, means all the details of first student, second student, and so on. All the students' details are. So like this, by using two CSV function, we can convert the given file to .2 CSV file. And if I wanted to mention only particular columns, I don't want all these columns. For example, if you see here, if I don't mention the columns, it is writing all the columns, names, percentages, ages, and grade and student ID. But out of these columns, I want you to write only names and percentages to that CSV file. So how to write here? See here, there is one attribute called as columns. Columns equal to, I wanted to write only names and so first close this CSV file. So if it is there means it will give a name access denied. So names and percentages I wanted to write. So copy this variable. The percentages I wanted to write to that CSV file. Execute this command. So go and check again. Go and check this folder. So and with if you see here, only names and percentages are written to this CSV file. Previously, it is written all names, ages, grades, and student ID, everything is written. Like this, if you mention, if you specify particular columns in which we wanted to return, it will return only that columns to the CSV file. So this is about how to write the values data frames to CSV file. In the next session, we will discuss some more topics. So thank you, friends. We will meet in the next session. In this session, we are going to see how to read an Excel file in Pandas. In order to read an Excel file in Pandas, it is providing one function, read underscore Excel function, which is used to read the Excel file. First, in order to use this function read underscore Excel, first I need to import Pandas. After importing, it will provide this read underscore Excel. Once if I read, whatever the operations we are able to perform by using CSV file, every operation we are able to perform by using Excel file. Open Jupyter Notebook. We are going to write the programs. Click on New. Import Pandas. Once if you import, it will provide one function read underscore Excel, which is used to read an Excel file. Here I will use some file which is there in my system. I have one file in my system. Files. Sample superstore data. I have one file. Sample superstore data. I will use this file. So this is an Excel file which is consist of the different fields like order date, ship mode, customer ID, customer name, country, city, state. entire sales data is there. I will use this file. I will copy this path, paste here, and also you need to give file name. Go here and rename this file so that you can copy this file name. And one more important point is check what is the type of this file. Properties. Here it is XLS. Sometimes it is XLSX. So you need to copy this file name here, the .xls. And after reading this file, it will create a data frame. It will create a data frame. Execute this, print data frame. It will create a data frame. Table-like structure, it will create rows and columns, it will create. Now we can do the required operations. If I wanted to print top 5 rows, print top 5 rows, we need to use head function, df dot head function, which will print top 5 rows. You see, it is printing top 5 rows. It is starting from 0 is nothing but it is printing up to 4 means it is printing 5 rows. You can see number of rows. If I wanted to print only top 1 row, head of 1, execute this, it will print only top 1 row. And if I wanted to print the last rows, df dot tail of tail method, which will print the last 5 rows. If I wanted to print only last 2 rows, df dot tail of 2, it will print last 2 rows. And if I wanted to access some particular records, then I need to use slice operation. For example, I wanted to access 2 to 5 records. 2 to 5 records. If I wanted to access fifth record also, then I need to give the range is 2 to 6. So see here, df 2 to 6 means it will print second, third, fourth, and fifth record. If I give 5, it will print only 2, 3, 4. If I want fifth record also, then I need to give 6. So this operation, this is start index, so this is end index. This operation we are going to call it as slice operation. Slice operation means we can retrieve the records which you want. You need to mention start index and end index. It is printing 2 to 5. If I give 5, it will print only up to 4. It will exclude the last index. So that you need to remember. If you need 5, then you need to give 6 here. And you can find minimum. For example, I wanted to find, if you go here, sales is my column name. I wanted to find minimum sales, maximum sales. So record, you need to give sales. So sales is my column. So df of sales. Here, whether it is small letter or capital letter, you need to give the same capital sales. Sales. I wanted to find the max value. What is the maximum sales happened in the sample superstore? It is 22,638. So what is the minimum sales? So I can give dot min. And so what is the standard deviation of sales? Dot std, which will give standard deviation of the sales. If I want a mean of the sales dot mean, it will give the mean of the sales. Like this, whatever the operations we performed on the CSV file, we are able to perform all the operations on sales, means in all the operations on Excel file also. So there is one more function, df.describe function, which will describe the numerical columns like sales, quantity, discount, profit, which will display the count of number of records which are not null. It is showing all 9994 for all the columns, means no null values are there. So it will show mean, standard deviation, minimum 25%, 50%, 75%. So max value, min value, it will show all the for all numerical columns. And then how to write the data to Excel file. Now the next concept is writing data to Excel file. Writing data to Excel file. Writing data to Excel file. In order to write the data to Excel file, the data frame, it is providing one function called as toExcel method, toExcel method, which is used to write the data to Excel. Read Excel, which is used to read the data from Excel. toExcel, which is used to write the data to Excel. Now see here, first I need to prepare a data frame. So go to Jupyter Notebook. Jupyter Notebook. These already in Excel, so you won't find difference whether it is written in Excel or not. Instead of using this data frame, I will create one more data frame. I will show you how it will write the data to Excel file. See here, first import pandas pd. Next, create a simple data frame pd dot data frame pd dot data frame. I will use key value pair, that is dictionary. In order to write the data, I will use key value pair, that is dictionary. Simple something, I will write student ID, student ID 101, 102, 103. I'm having some 3 students in my class, and student marks, student marks 900, 978, 500, and so on. And then the name of the student. For example, I have 3 columns, name of the student. Ishwar, Srinivas, and Rakesh. I have these students info. I wanted to write this to Excel. So after preparing a data frame, it will create a data frame df student something. I will name this data frame as df student. By using this df student, my data frame is df student dot df student dot to Excel method, to Excel method, which is used to write the data to the Excel. I will give this name as something marks weather dot xlx. I will give this name as in order to use this Excel to Excel function. So I need to use one more. See here with pd dot. So you need to use this function Excel writer function, Excel writer function. Here I need to mention something marks, student details. I need to give this Excel name, student details dot XLSX. Either you can give XLS or XLSX as a writer, For this I need to mention so df dot to Excel, the writer df student dot to excel writer. Execute this. Here it is not a variable, it is not a string, it is a variable. Means from this, for this Excel sheet, so what it will write means, it will write this df student, whatever the student details are there, right? It will write this data in Excel file. Here it is capital W, write this. Go and check. If I give the full path, something like C colon something files folder, in that if I am creating student details, it will create the file in this folder. If I don't give any path, by default it will create file in current working directory. The current working directory, go to this, the where means pandas examples. If you see here student details, so go and open this. So whatever student ID, student marks and name. So I have given these three student details. It is storing in Excel file. If you see the properties, it is XLSX file. So like this, we can store the data. For example, if I have multiple data frames, I wanted to write multiple data frames. Here, open Jupyter Notebook. One more data frame is there. I wanted to create, if you observe Excel sheet, we can create multiple sheets. Only one Excel, but we can write multiple sheets. For example, see here, I can create one more sheet, one more sheet. So like this, I can create multiple sheets. See here how to write multiple sheets data. Create one more data frame. Something faculty info. Instead of student, I have faculty. One more data frame is faculty. And here pd dot data frame faculty ID, something 1000, 1001, 1002, and so on. And so just I have faculty names. So this is about faculty data frame. How to write multiple sheets. See here, student underscore faculty details. I will create Excel sheet name student underscore faculty underscore details dot XLSX writer. I have two data frames, right? How to write two data frames. So df student, first data frame is df student dot to Excel. Here I need to mention sheet name equal to students. And similarly, I wanted to write faculty data frame. So that is df underscore faculty dot to Excel sheet name equal to faculty. I wanted to change the sheet name is faculty. Execute this. So once go and check, if I give the full path, it will store in that path. If I don't give any path, it will store in current working directory. So go and open this folder. If you see here, student faculty details, open. You can see first sheet name is students and second sheet name is faculty. So if you open faculty ID and faculty names are there. If you open students, student ID, student name and student marks are. So like this, we can write multiple sheets at a time to the Excel by using this process. I need to prepare data frames for each sheet and then use pd.excel writer to write the data to this Excel file. And you need to mention that data frame.to Excel and second data frame. If you have n data frames, so you can write n sheets to that Excel file. So thank you, friends. In the next session, we will discuss some more. In this session, we are going to discuss how to treat missing values in Excel file or CSV file. So whatever the data set we are going to get, so how to fill the missing value. This is one of the important step in any machine learning algorithms. So before starting any machine learning algorithm, before applying any machine learning algorithm, one of the important step is filling or treating the missing value. Why filling missing values or treating missing values is important is, for example, some column 1, it is having, so total rows are some 2000 rows. The total records I have 2000 records, but in column 1, so there are some 257 values or 250 values are missing, and column 2, something around some 124 values are missing, and column 3, so no values missed, means it is completely 2000 rows are there, so no missing values. Like this, if I have some 10 columns, so there are some columns which values are missed. If I don't consider these missing values, if I don't fill or if I don't handle these missing values, it will impact performance of the model. Performance of the model. Why it will impact means, maybe due to this, I'm not considering these missing values. There may be some relationship we are missing. Maybe the relationship between column 1 and column 2 or column 3 will be there. Some relationship is there. Wherever the values are missed, we may missing some relationship between those columns. So missing data, it is one of the important missing data in the training data. The training data can reduce the power, power or fit of a model, As I told, if I miss this, there may be a chance of reducing the performance of the model. So why it will reduce a model means, because we have not analyzed behavior and and relationship with other variables correctly. With other variables, so if there are some missing values in column 1 that may be related to with other column 2, but due to these missing values, I'm not able to find what exactly the relationship between those columns. That's why it is one of the important steps while filling the missing values. Now in today's session, we will see how to treat these missing values. How to treating missing values. Treating missing values. We will see there are a lot of techniques are there. We can use those techniques to fill missing values. First, we have some methods like fill NA and drop NA method. The fill NA function, first we will see fill NA function, which is used to fill the missing values, which is used to fill the missing values, or if there is a not null, not a number values, if you save, means if you read CSV or Excel file in the data frame, it will store as a not a number if it is a null or empty value. Not a number, we need to handle, which is used to fill missing values or not a number values in Pandas data frame, which is used to fill the missing values or not a number values in Pandas data frame. Pandas data frame with suitable data as decided by user. What is the suitable data we will see. And drop NA method which is used to remove the row, which is used to remove the row or column from data frame which is having missing values. Opposite to fill NA which is used to fill those values, but drop NA it will drop completely, means it will delete complete row or column which is having missing value. Now, first I will read the data. First I will read some Excel file or some CSV file. First I will show what is the missing value, and then I will try to apply fill NA and drop NA methods for that. Open Jupyter Notebook. Jupyter space notebook. Click on new. First, in order to use Pandas, import Pandas as PD. I have one Excel file in my system to fill any example. Here it is having some missing values. If you see here in this column, here some missing values. Here also some missing values. I wanted to fill these missing values by the fill NA and drop NA. So it is Excel file. In Pandas, there is one method called as read underscore Excel, which is used to read that Excel file. I need to use this file path. And also I need to mention the file name, fill any example, properties, it is XLSX file. I will copy this file name, XLSX. So this is the format of this file. After reading, it will store in a data frame. Print data frame. It is having all these rows. If you see here, wherever the value is missing in the data frame, it will save it as a NaN. So NaN is not nothing but not a number. So wherever the values are missed, if you see Excel, so here are the values are missed. Here the values are missed. So wherever the values are missed, it is saved as a NaN in data frame. Now I need to handle this. So first, fill the values with 0. First, I will use one syntax, fill the values with 0. 0 nothing but I don't know that value. So just I'm saving that, means I'm filling that NaN value with 0. See here, new data frame equal to data frame dot one method fill NA method. I wanted to fill it with a 0, new data frame. Execute this. First, I need to declare this data frame, right? New data frame equal to here spelling mistake fill NA FILL NA. Execute this. It is created in new data frame. See first example in the second row it is NaN is there in temperature. Now it is filled with 0. In the event column also see here in the fourth row it is NaN. Here fourth row it is filled with 0. So what this fill NA method is doing, it is filling with a specified value wherever the value is missing. Here I used to fill NA of 0, it is filling with 0. But if you observe temperature, it is a number. Wind speed, it is a number. But even it is rainy, sunny, and cloudy. If I will fill with a 0, there is no meaning. Means it is a string, but I am filling with something 0. So 0 is no meaning. Instead of that, I wanted to print a no event. Instead of filling with a 0, I wanted to print with no meaning. So fill NA. So temperature and wind speed, I wanted to fill with 0, but event column, I wanted to fill with no event. See here how I am going to fill new data frame equal to df dot fill NA method only, fill NA method only. Here I need to use dictionary format, key value pair, means column name and which value I wanted to fill, I need to mention. So first one is temperature column. I wanted to fill temperature with a 0, and next column, that also I wanted to fill with a 0, and last column, event column, I wanted to fill it with, I wanted to fill it with no event. Instead of filling with 0, I wanted to fill with no event. So second column name is wind speed, and third column name is event. Observe the output. Now instead of filling with 0 in the event column, now it will fill with no event. New data frame. Execute this. See here, wherever the value missed in event column, now it is filled with no event instead of 0. Now it is somewhat meaning, instead of filling event with a 0, no event means the user will understand there is no event in that particular way. Now, so there are different methods. This is method 1. So method 1, use fill any method, fill with specified value. Here I need to mention specified value. If it is maybe 0 or some other no event, you need to specify the value. If I wanted to fill multiple different values, then I need to give dictionary as input. Key value pair, key will be the column name and value is which value you wanted to fill. Next, second method. Second method is drop NA. The second method is drop NA. Drop NA. So drop the column completely using drop function. It is particular, means which is having large number of missing values, means based on the business criteria. If I wanted to remove the columns which is having minimum 25% of missing values or 75% of missing values, based on the customer or based on the user, we can remove all the complete column if it is having more missing value. See here, new data frame equal to data frame dot drop NA, and execute this new data frame. See here, previously it is filling with some missing value. Now drop NA method, it will remove all the columns which is having null values, or it will remove all the records which is having null records. If you see, totally 9 records are there. Now after eliminating those null columns, it is having only 3 records. But this method drop NA, so don't apply while using machine learning. What it will do means it will remove all the columns which are having null values. But we will lose lot of information if you simply remove drop NA method, because there may be some relationship with one column to another column. If I remove those records, it will affect the performance of the model in future predictions. This drop NA method rarely you can use. When you are going to use means almost all the columns values are missed. Means there are 9 columns are there. In all the 9 columns values are missed. In some 100 records or 1000 records, in that case, apply drop any, which is having all the records are missed. This is method 2. Next, method 3. Method 3. In the method 3, so fill NA method with mean value of that particular column. Mean value of the column means, for example, in temperature column values are missing. Instead of filling with either 0 or some specified value, I wanted to fill this with mean of this column. See here, first I will print df data frame. Here if you see temperature column, we have 32, 28. Other than NaN values, it is 32, 28, 32, 34, 40. So 4 values are not missed, 5 values. So 1, 2, 3, 4, and 5 remaining values are missed. So open calculator. So you can calculate here 32 plus 28 plus 32 plus 34 plus 40. The total 166. But how many rows we have values is 5 rows. So divide by 5. It is approximately 33.2. See here, if I apply mean value here, new df equal to df dot na fill na, and for this I wanted to print, means I wanted to fill with mean values of the column. Now print new df. If you observe, if it is a numerical or floating point value, it is replacing whatever we calculated 33.2, means it is the mean. Here also it is missing, and here also it is missing, here also it is missing. In the missed value place, it will replace with that mean of the column. But if it is a string, here also it is a float in wind speed, but if it is a even, it is a string, it won't replace because it won't know what is rainy plus sunny plus snow plus by something. It won't know what is the average of those strings, means it is not possible to calculate mean of that. Instead of that, it will means it won't replace anything in that string column if I use mean. Similarly, I can fill with median. So copy paste this instead of mean. If I wanted to fill with median, means middle value. So if I execute this 32, so 32, 28, 32. Similarly, calculate here 32, 28, and 32, 34, and 40. If you see middle value is 32. Now it will replace with 32, not with median. That means if I calculate median, so what it will do means middle value it will take. It will replace fill missing values with median value. Median is nothing but middle value of this records. So 32, 28, 32, 34, 40. The middle value is 32. It will replace with 32. Execute this. Wherever the value is missing, it will replace with 32. It will replace the value with. It is applicable same as in the first string. It is not possible to replace with mean or median value. So next method 5. mode. Method 5 mode. So what is mode? Advantage here. So what is the advantage of mode here? We'll copy this. See here, instead of median, I wanted to mention mode. So what is the advantage here? See here, see here, mode. Mode is nothing but most repeated value. So 32 mode is nothing but most repeated value. Fill in a DF mode. Actually, you have doubt here. So it is replacing with NaN only. So why it is replacing with NaN only means here mode is nothing but which is having most repeated value, which is most repeated value. Here if you see normal table here, most repeated value here it is NaN. Here if you see most repeated value NaN only, not median. Just to take mode, see here mode, execute this. If you see here, mode is nothing but which is most repeated value. Here, if you see as per computer, it will understand most repeated value is NaN. So that's why it is replacing with NaN only, not with other value. Here also NaN only. Now, how to replace with the middle means most repeated value with the available value means 32, 28, 32, 34, 40. Here most repeated value in this column is 32. Means 32 is repeated twice. Here if you see 6, 9, so original data frame, print data frame. Here if you see most repeated value is 6, 9, 7, 8, 12. Here in the event rainy, sunny, rainy, rainy 2 times, sunny 3 times. Means sunny is most repeated value. How to replace with this most repeated value? See here, I will write some for loop per column in new data frame dot columns. For each column in new data frame, see here, new data frame of column means for each column new data frame dot fill na new data frame of column dot mode sub 0 comma in place equal to true. If you give in place, then only it will represent original data frame. Otherwise, if you don't give this in place equal to true, it won't change the original data frame. See here, original data frame means this new df. Only for printing it will change if I don't give this in place. If I wanted to change within this data frame, so then I need to use in place equal to. So print this new data frame. Now you can see most repeated value 32 is changed, replaced in this missing values. If you see here, wherever it is missing, Sunny got replaced. Wherever the value is missed, it is replacing with the most repeated value. So what is mode is? Mode will replace with most repeated value. Now there are two more methods, method 6 and method 7. Method 6 forward fill and method 7 backward fill. Backward fill. What these two methods we will see. First I will print a data frame Forward fill means it will fill the value with previous value. If you see here in the second row, NAN is there, it will fill with the previous value 32. If you see here NAN, this will fill with 28. And if you see here NAN, it will fill with 32. Like this, here NAN means it will fill with snow, and here NAN means it will fill with sun. Forward fill, it will fill the missing value with the previous value. Forward fill, it will fill the missing value with the previous value. See here, new data frame equal to new data frame equal to data frame dot fill NA. So there is one attribute for fill NA, method equal to forward fill, F fill. And now print a new data frame. Execute this. If you see here, second row, there is one missing value, it is filled with 32. And fourth row, it is a missing value, it will fill with 28. And here last two rows, fifth and sixth row. So before 34, if you see here, these two values are filled with previous value. And here in the fourth row, NaN will fill with snow. It will fill with snow with the previous value. So forward fill means it will fill the missing value with the previous value, and backward fill I will show. If you see here, backward fill, it will fill with the next value. Here it will fill with 28, here it will fill with rainy, and here it will fill with cloudy. So what is backward fill is, it will fill the value with the next value. Now apply this code. In method, I will use bfill. Bfill. Instead of ffill, I need to use bfill. Execute this. Now if you see here, this 28 is filled with the previous value. And here this NaN is filled with not previous value, it is next value. It will fill with next value, rainy. So like this, wherever it is missed, for example, here from last to third row, it will fill with cloudy. From last to third row, it will fill with cloudy. So with the next value, it will replace. Now last method is, if you see data frame, it is filling. If I apply fill NA, it is filling all values. For example, if you see here, there are two missing values, and here there are three missing values. It is filling all missing values, but I don't want it to fill. If there are here, if you see, there are three missing values, I wanted to fill only one, or I wanted to fill only two, so last two, or I wanted to fill all three. So see here how to fill missing values. There is one more attribute called as limit attribute, which is used to limit the number of records to fill this missing value. So after using, either you can use forward fill or backward fill. For example, forward fill, comma, there is one more attribute, limit equal to 1. So what it will do means, even two values are missing, it will fill only one value. Here there are three values are missing, it will fill only one value. Forward fill means with previous value it is going to fill. If you see here, there are three missing values here, but it is filling only one value because I given limit equal to 1. If I give limit equal to 2, it will fill two missing values, sequential missing values. If you see here, there are two values got filled and it is leaving this third field. Like that, number of values which you wanted to fill, you need to specify. It will limit those many records. So thank you, friends. This is about filling missing values in data frame. In the next class, we will discuss some more topics in Pandas. In today's session, we are going to discuss about time series analysis in Pandas. So what is exactly time series? How to perform a time series in Pandas? Actually, when it is developed, originally it is developed for financial time series such as stock price estimates, means what will be the stock prices yesterday or day before yesterday or 6 months back. Based on that, I can plan my stock market prices for the next month or next year, so that it is originally developed for stock market prices, but later it is not restricted to only stock market prices. It can including business. So there are different other domains like business, science, engineering, science, engineering, and there are a lot of domains like public health. For example, some clinic or some hospital is there, so they wanted to plan a number of doctors or number of pharmacy details for the future. What will be the past data in time series? Based on that time, they will find the trend in what will be there in that data, and they will plan the new pharmacy details. Like that, it is not restricted to only stock market prices. It can be applied in business, science, engineering, public health, and so on. Wherever the time involves, we can apply this time series analysis. Next, so examining the details during specific time periods of interest. Nothing but I wanted to examine. So what is the sales in 2019 September, or what is the sales of 2018 December, 2017 August. So what is the sales? What is the mean sales? What is the trend? So how the sales happen? What is the profit? So based on the time, I wanted to examine specific period of interest. Then I can apply time series analysis. And in broadest definition, time series is a data set where the values are measured at different points in a time. For example, I can measure the data at hours wise, or for example, weather data. I wanted to measure the weather measurements, specific frequency. For example, hourly weather measurements, hourly weather measurements. If you on TV, they will show in this day, so 24 degrees centigrades or something means they will display the weather measurements, and they can future weather means whether it will rain or not. So based on the previous some 10 years data, 20 years data, so they will take this if this is the weather, there is a chances of getting the rain. So they will measure the data based on the point of time. So hourly weather measurement or daily counts of website visits, daily counts of website visits, and monthly sales totals, monthly sales total. Wherever the time involves, we can apply time series analysis. So why we need time series? The next question is why I need to analyze time series. So why need time series? Why need time series? Time series help us to understand past trends. Time series help us to understand, help us to understand past trend, past trend, so that we can forecast, so that we can forecast, can forecast, and we can plan the forecast, and we can plan, we can plan for the future. We can plan for the future. For example, so just I will take some simple example. There is a coffee shop, coffee shop. So he is having last month data or last 6 months data. So he is having last 6 months data. Last 6 months data, how many customers are coming, customer details, first month data. For example, he started on Jan 2020, coffee shop, and he is having all customer details, and then means how many customers are coming daily, so what kind of whether brew coffee sale or any other tea sale or ginger tea sale, Means he is having the total details like January, February month 2020 and March month. Based on that data, he can plan how much coffee he has to prepare. Means in the March month, based on the previous data, based on the time, for example, today these many persons came. Based on that, he can plan for the next one. So that is nothing but time series analysis. Based on the time, we can plan for the future. So then we require time series. We require time series. Next, we will see practical example how to do time series in example. I'm having some Apple stores data. Apple stores data. Apple store data. I wanted to predict some month data, their sales are mean. So I wanted to predict for some particular month. So what is the pre-processing I have to do in Pandas data? First, I will read the data in a data frame. So what is the pre-processing techniques I need to apply and how to calculate the time series data in Pandas? We will see with an example. So open Jupyter Notebook. Open Jupyter Notebook. So I have created one folder called as Pandas examples. From this, I will open Jupyter Notebook. Click on New, Python 3. So in order to work with Pandas, first we need to import Pandas. Import Pandas as PD. Next, I have one CSV file. In files folder, I have that file. So Apple stores data. So this is Apple stores data. Their high, low sales, close sales, adjective close sales, volume. So open stock or open details. So complete details with along I have date column. So wherever the date column is there, I can apply this time series data. Now see here, it is a CSV file. So df equal to data frame equal to pd dot read underscore CSV. I need to mention that file path. So the file is available in this folder. So based on your system where it is stored, you can give that path here. And file name is aapl.csv. Apple stores data. aapl.csv. First print top 5 records by using head method, which will print top 5 records. Top 5 records by default. So the date in a data frame is, the data frame is a string. So date in a data frame is string. So for example, date column. So this is date column. I wanted to print type of date. Type of date. So df dot data. So first column data type I will print. First column, first value, data type I will print. So df dot. So here it is a case sensitive. So column is capital D, right? You need to give capital D. Execute this. You can see it is a string data type. By default, date in a data frame is string. First, I need to convert that as a date column. So see here. So there is one attribute in data frame. So while reading file only, there is one attribute called as parse dates. Parse dates, which is used to parse the, means which is used to convert date type column instead of string. So my case, it is a date column. I need to convert this date column instead of string. I wanted to convert it as a date. See here, this is to read the file. While reading only, so there is one more attribute, parse dates, What's dates? I need to mention the date column. So date column. Now see here. So now date is, but it is showing similar. Now I will type this, the type of this date column now. Now you can see it is a timestamp. Nothing but it is converted into, instead of string, now it is converted into timestamp. That is date and time. First important step is I have to set index as date. Index as, previously if you see, the indexes are some other than 0, 1, 2, 3, 4, 5 and so on. But if I wanted to print some particular date column, date value, or particular date or particular month data, so then I need to set index as a date, not these default values. In order to set index as a date, so there is one more attribute while reading, index call. So for that, I need to mention this date column. The first step is I need to set date as a index. Parse the dates. It is used to parse the date column. After that, there is one more attribute called as index call, which is used to set the index for the data frame. The index column is I wanted to set date as a index column. Now execute again. Now you can see instead of 0, 1, 2, 3, now date column is a index. Previously it is 0, 1, 2, 3 and so on. Now date is a index. I wanted to retrieve some sales of 2019 8th month, August month sales. For example, retrieve August month sales. August month sales of 2019. Sales of 2019. So how to retrieve August month sales of 2019 is, so my data frame is DF. Now date time is an index. You can give like this 2019 and 8th month. Execute this. You can get all the sales of 2019 8th month. If you see the date column, all the sales of 2019 8th month only. So there is no other data except, means from 8th month first date to 30th date is displaying all the details of this particular month. The advantage here is I can retrieve granularity wise, means I can retrieve month wise or year wise or hours wise. So granularity is an important concept. The granularity wise, I can retrieve particular month or particular year or quarterly or half yearly. Means I can go for particular granularity. Here I am retrieving 2019 8th month. Next, retrieve closed prices in 2019 8th month. So retrieve, here if there is one more column as close column, I wanted to retrieve all the prices. So in close column in this 2019 8th month. So retrieve, next requirement is, so previously I need to retrieve, this is first requirement, I need to retrieve all the values in this 2019 8th month. Now my requirement is retrieve all closed prices in August 2019. August 2019. See here DF 2019 8th month dot close. First to see the spelling, it is capital C. Then I need to give the same, otherwise it will give error. Dot close. It will return date and corresponding closed prices. If I want low prices or high prices or volume, so whatever you want, that particular month, you can print that particular month closed price. Now the requirement is retrieve all closed prices of their means. Closed prices mean retrieve closed prices mean per August 2019 month. So DF 2019 August month dot closed prices dot mean, which will return mean value of that particular month is closed price. Similarly, I wanted to print something low values mean, low value mean, low value mean. And also I wanted to find max value, something for low prices, max value. The max value. So I can use max method. I can get the values like this. I want min values. I can apply min function. So like this particular month I require the data means I can get that data. So we will try to access complete year-wise data. So 2019. So I'm getting complete 2019 data. If I want 2020 data, I can get 2020 data. It will retrieve only 2020 data. From the 2020 data, I wanted to find the mean value of that closed prices. Dot closed prices. From this, I wanted to find mean. Execute this. So this is year-wise data. This is month-wise data. Like that, based on our requirement, based on our granularity, we can perform time series analysis on the given. Thank you, friends. In the next session, we will discuss some more topics. In today's session, we are going to discuss about replace function, which is available in Pandas. So what is a replace function is, a replace function will take two parameters, two values as input, or nothing but two parameters as input. One is the value to be replaced, and another is the new value, and another is new value with which we are going to replace, with which it will replace. It will replace. So what it means we will see. I have one CSV file with me. It is a CSV file. It is Excel file. Okay. So I'm going to read this Excel file. If you see some default values are there, how to replace these default values? So we are going to see with practical. So open Jupyter Notebook. Jupyter space notebook. So usually in live applications, they will use some default values, 999 or 49s or 888s or 48s or 777 or 47s. Means they will indicate something not applicable, not stated. So if they wanted to use indicate, they will replace with, they will indicate with some default values. If there are any default values in my program, how to replace those values? Click on new, click on Python 3. So in order to work with pandas, import pandas SPD. So I have one Excel file pd.read underscore Excel and file path. The file path is here. So you need to give your file path where it is stored. Replace dot Excel. This is file extension. So print top 5 records by using head method. Execute this. It is printing top 5 records. Don't use just print because only few records are there. Totally 8 records. If you see here, it is indicated minus strip 49s, minus 48s, and something, some default values are there in this Excel file. So now first task is I have read by using a read underscore Excel method. Now, so there is one function replace function. There is one function replace function. See here, new df equal to, I will import numpy also, numpy as np, new data frame equal to df dot replace function. For this replace function, I need to give the old value, that is minus 4 nines, minus 4 nines. I wanted to replace instead of minus 4 nines, because if it is minus 4 nines or minus 4 8s, if I find some average here, it will give some wrong value. I don't want to calculate these default values because these are for some specific purpose, maybe not stated or not there, something not applicable. They indicated with some default values. But if I calculate min or max or mean or standard deviation, it will give the wrong value. Instead of that, I wanted to replace with something not a number only. See here, in NumPy we have n, a, n, so not a number constant, not a number constant. Now print new df. See here, now wherever minus 4 nines are there. So here in the second row, second column, fourth row, second column, second row, second column, fourth row, second column. Whereas wherever minus 4 nines are there, it is replaced with np dot, means numpy dot, not a number constant. It is replaced with not a number constant. Now here only minus 4 nines are replaced. I wanted to replace minus 48 also, means I wanted to replace multiple values. If we wanted to replace multiple values, see here, I wanted to replace at a time minus 4 nines and minus 48 constant with some other, that is np dot, not a number constant. See here, in the previous example, I specified only minus 4 nines. Now I will make it as a list. I will add minus 48 also, to replace minus 48s also with not a number. Execute this. Now minus 48s also replaced with not a number. Now see here, event column, it is having some, instead of rainy, snow, sunny, 0 is nothing but some default value, something 0 is there. Instead of 0, I wanted to replace this 0 also not a number. So not a number, NaN constant. Different columns, I wanted to replace with different, here, see, multiple columns at a time. I wanted to replace new data frame equal to df dot replace, for replace I wanted to give it as a dictionary. First column is temperature, temperature, temperature. In temperature I wanted to replace only minus 4 nines only. I don't want to replace minus 4 8s. So how to replace it? See here, minus 4 nines, comma. Second column is wind speed, wind speed also wherever minus 4 nines is there, I want to replace here, and event column, event column. In event column, 0 is there. I wanted to replace 0 with not a number. Here see np dot not a number. np dot not a number. Now print new df, new data frame. See here. Now 0 also replaced with not a number. We can replace multiple columns and their values also by using this replace function. Now my question is here, the next task is replace one list values with other list of values. Next we will see replacing one list values with other list of values, other list of values. See here some data frame is there, some data frame. So df equal to pd dot data frame, pd dot data frame. I'm having some list of students and their score something good and exceptional, exceptional and average and poor, and one more student is good. I'm having the details like this, and students in my class are like this. Name, student, just I will give student. See here, list of students are like this. Easter and Akem and Srinivas. So totally how many values are there? 1, 2, 3, 4 and 5. I will declare 5 students. Rakesh and Vinod. So some 5 students and their score means whether they are good or exceptional, average or poor. So their details are there. Now print a data frame. So score and student name is there. So my requirement is instead of this good, exceptional or average or poor or good. So I wanted to replace good means exceptional means 1, good is 2 and average is 3, poor is 4. Like that I wanted to replace. See here, new data frame equal to data frame dot replace of my list of values are like this: good, exceptional, exceptional and average and poor, average and poor. So this list of values I want to replace with, so good means 2, exceptional means 1, average means 3 and so poor means 4. Now print a new data frame, execute this. Now you can see wherever good is there, it is replaced with a 2 and exceptional means 1. So next average means 3 and poor means 4. Like this, we can replace one list values with another list, or we can replace old value with a new value by using replace function. So thank you friends. In the next class, we will discuss other topics. In today's session, we are going to discuss about resampling the data. So what is resampling the data? How to resample the given data into different days or means. So what is resampling? Resampling is nothing but the data can be resampled as the data can be resampled as week or day or month or quarter or yearly or business days and so on. Business days and so on. Means, for example, they will give the data in a day-wise format. For example, 2019, some 8th month and 2nd day and 3rd day and 4th day and so on. So if they give the data in day-wise, we maybe need to resample the data weekly or day, already day is given, and month-wise or quarterly or yearly. Means we need to group the data in different resampled ways. In order to resample the different ways, so we have some special function is available. I will show that one. First, I have some Apple data. Apple data. I will use this Apple data. It is having some sales, low, high, open, and particular. It is given the day-wise data, and all the sales related data is given. I wanted to resample into month-wise or quarterly or yearly, and I wanted to see the different visualizations. So first, open Jupyter Notebook. Open Jupyter Notebook. Click on New. It will open the cell. In order to work with pandas, first import pandas as PD. And in order to read, this is a CSV file, read underscore CSV, read underscore CSV, which will read the CSV file. For this, I need to give PD dot read underscore CV. Pandas having one function called as read underscore CSV to read CSV file. For this, I need to mention the path of the file. So this is my file path. It will construct a data frame. On that data frame, I will resample the data. This is my file, the print top 5 records. So these are the top 5 records. If you see here, date column, by default, it is not a date format. Type of this date column, it is not a date format. So it is in some series format. First of all, we need to convert this into date format. See here, I will construct one more data frame. So there is one attribute called as parts dates attributes. Parts dates attribute. Parts dates. For this, I need to mention the date column. Now print df1 type of this date column. After using this parts dates, so what is the type of this date column? Execute this. Wait here. Here one brace is missing. Execute this. Now still it is showing a date. See here what we will do. See here, instead of this type of df1 dot date column, I need to print because it is a series of values. It will give series. So instead of that, I wanted to check particular first a date type. Execute this. Now it is a timestamp. See once again I will execute this. First, instead of this, I will mention df dot date column of 0. See here, now it is a string. By default, it is a string. After applying this parse dates, now it will become timestamp. After getting timestamp, even then, if I need to resample the data, first I need to set it as a index. See here, set it as a index. There is one more attribute. There is one more attribute, index call attribute. For this, if I mention date as a input, it will set date column as a index. Now print df1 dot head method to print of 5 records. Now you can see the previous output. It is having 0, 1, 2, 3, some sequential numbers. Now if you see this output, it is having the indexes, the date, time column. Now we can resample the data based on our requirement. First requirement 1 is requirement 1. Resample the data. Resample the stock prices monthly. Stock prices monthly means in this Excel file. So these closed prices I'm going to consider. Instead of these individual prices, I will take that month close prices mean. So that month mean prices I'm going to take for every month mean prices. See here. So go to Jupyter Notebook, df dot. So my column name is closed prices. There is one function called as resample function. If I wanted to resample monthly wise, I need to provide the attribute m, and I wanted to find mean of each month. So df1, so new data frame is df1 dot close of dot resample of m dot mean. If you see here, 6th month mean price, 7th month mean price, and 8th month mean price, 9th month mean price, and so on. It is giving mean prices for each month. Now I can construct a matplotlib chart. See here how I am going to construct matplotlib chart. I will plot all these points. Means whatever the points I have got, I will plot one chart for this. Percentage matplotlib inline. So I am importing that matplotlib inline, and then see here up to this I will take after finding the mean. After finding the mean, I will plot a graph. I will plot a graph. See here, so the month wise, June month, July month, August month, September month, October, November, December. So monthly wise, it is constructed a chart. It is resampling the data. Original data, it is day wise. After resampling the data, I have resampled into month wise. I am getting the chart. And next requirement, resample the data quarterly prices. Next requirement is resample the data quarterly prices. Quarterly prices. Here take the same code. Instead of m, we are going to take q. Q is nothing but quarterly prices. For that closed prices, I am taking quarterly. Execute this. If you see here, quarter 2, quarter 3, quarter 4, and 2020. So now it is June. So that is quarter 1 is January to March, and quarter 2 is April to June. Like that, it will resample the data quarterly. Quarterly is nothing but 3 months. So 3 months in a, so for every 3 months, it will consider one quarter. So quarter 1, so January to March, and April to June, one quarter. So July, August, September is one quarter. October, November, December is another. This is quarterly resampling the data, and I can see so what are the prices, mean prices for each quarter. So next, resample the data weekly. Resample the data weekly. Resample the data. See here, I will take the same code. Instead of here M, so I need to give W, which will resample the data weekly. Here, if you see July, so there are 4 weeks, and August 4 weeks, and September 4 weeks, and so on. Means for each month it is having 4 weeks. So that 4 weeks data it is representing. If you see granularity, first it is monthly, somewhat higher granular, and next to quarterly it is higher level granular, and weekly it is lower level granularity. And similarly, instead of this chart, I wanted to plot a bar chart. How to plot a bar chart is, here there is one attribute for this. One attribute for this plot, kind equal to bar chart. Execute this. You can get a bar. Instead of weekly, I will take quarterly, or if you see weekly, so there will be some mess. Instead of that, we will observe this bar chart for quarterly. So for each quarter, if you see what are the mean prices in the bar chart. We can also plot the data yearly. See here, yearly data. For yearly, I need to mention Y. It will gives you yearly data, 2019 data and 2020 data. So like this, we can resample the data year-wise, monthly, quarterly, and day-wise, weekly. We can, based on our requirement, we can resample the data by using this resample method. So thank you, friends. In the next class, we will meet with some other new topic. In this session, we are going to discuss about Pandas statistics function. Means what are the different statistical functions available, how to perform on a data frame or series. So we will see something about all these functions. Just I will give a brief introduction of it. A large number of methods collectively compute compute descriptive statistics descriptive statistics and other related operations on a and other related operations on a data frame or series. So there are a lot of methods are available which will do these statistical operations on a data frame or series. Some sample operations are like this. Count function, which is used to count number of non-null observations in the data frame, and sum function, which is used to find the sum of all the values, and mean to find the mean of the values, median to find the middle value. Median is nothing but middle value, and mean mode means most repeated value, most repeated value. Mean means all the sum of all values by total number of values. Standard deviation, minimum value, maximum value, absolute value means in that column if there is any negative values means it will convert those values into positive value. Product, cumulative sum, cumulative product. All this we will see with an example. Now I will create a data frame. By default, all these operations which will perform column wise. All these operations by default it will perform column wise, that is index wise. And if I need row wise, I need to mention axis equal to 1. So then only it will perform row wise. By default, it will perform column wise. If I need row wise, I need to mention axis equal to. So what it means, I will show you. I will take this data frame. I need to construct a data frame. I have one dictionary, name, age, and rating. So names of all the persons and ages of the persons and rating of the persons. Here key and value I am taking as a series, which I am creating all series of values of ratings of all those persons, ages of the persons, and name of the person. So open Jupyter Notebook. First import pandas. Click on new, import pandas, and then I will create a data frame. I will perform those statistical operations. Import pandas as PD. I'm declaring one dictionary which consists of name, age, and rating. For this dictionary, I am creating a data frame equal to df dot, not df, that is pandas dot data frame of dictionary I will give, and I will print this data frame. Now see the data frame is created with the columns name, age, and rating, and indexes it is given starting from 0 to 11, and all the values it is created as a data frame. The first function is sum function. So based on the requested access, by default it will do column wise sum, and if I mention access equal to 1, it will do row wise sum. And if the column is completely string values, if the column contains all the values as a string, what it will do means concatenation of strings. If it is all integers and floats, there is no issues. If it is a string, then it will concatenate all those strings. Go to our Jupyter notebook. This is my data frame df. For this data frame, first do sum of values, print df dot sum function, execute it. By default, if you see here, it is doing column wise name, age, and rating. If you see name is a string, all are the strings Ishwar, Akim, Rakesh, Varun, Srinivas, and Sakit. So all those are strings. What it is doing, it is concatenating all those strings. And if it is an integer or float, it will do the sum of all those values. If I need row wise, print df dot sum function row wise sum I wanted to find. Here I need to mention the integer is 1. So 1 is nothing but it is a row wise sum. Execute this. So row wise sum, what it will do means it will add only integer and floats. It will not add these strings. If all are the strings, then it will add. But here some of the integers, some of the floats, it is possible to add integer plus float, that is 25 plus 4.23, that is 29.23. Like that, each record, each row it is adding, it is making the sum. So this is sum function. Like that, I can do mean, median, mode, standard deviation. See here, first I will apply mean function. How it will calculate the mean is, so total values by number of values. Total sum by number of values. That is number is, here I have created 12 rows. So here the number is 12. If it is a column wise, for example, age, it will add 25 plus 26 plus 25, all these values by 12. See here, df dot mean, so print df dot mean function. Next, like that, I can do median, df dot median. Median means middle value, and I can do standard deviation into df dot std. which will return the standard deviation. And for example, I will use ABS method, absolute method. So by using absolute method, so it will return the absolute values for that column. It will return absolute value for that column. ABS, DF, something my column name is. So first, before that, what I will do, I will create covariance, correlation, because if you see here, there is no negative values, you cannot understand. So whether it is doing all the negative values to positive value or not, I will calculate covariance and correlation. So if there are negatively correlated means we can get the negative values. So there I will convert into positive value, then you can understand. So before that, in order to summarize this table data frame, so there is one method, describe method, which will summarize all this data frame. Summarize nothing but it will give count, mean, standard deviation, minimum 25%, 50%, 75%, maximum value for only integer and floating columns, not for the string. Means for the string, it is not possible to calculate the mean, median, or sum or standard deviation or 25%. For string, it is not possible. For integers and float, it is possible. It is possible to find count, mean, std, minimum, 25%, 50%, max. So it is used to describe the data frame. And next there is a method called as covariance. Covariance, which will calculate the covariance between columns or between all the columns. Covariance between particular two columns or covariance between all the columns. So there is a method called as COV, which is used to calculate the covariance in the data frame column. See here how I am going to calculate covariance. For calculating covariance, something I will use one data frame. See here, I will create a new data frame, a df equal to pd dot data frame. I will use some numpy random number to generate some random numbers. I wanted to find covariance. If I use some particular values, instead of that, I will use some random numbers, numpy random numbers method. So which will generate sometimes negative values, sometimes positive values. It will generate np dot random number random number. I'm generating some 10 rows and 5 columns, and I will name the columns like this. Columns equal to A, B, C, D, and E. So I'm generating 5 columns. What this random number means, it will generate 10 rows and each column some random number, 5 random number. See the output here. First I will see the output, what it is generating. See here, rand n. Here's some spelling mistake, columns. See here, it is generating some negative values, some positive values. Here, I will calculate the covariance between two columns. See here, covariance between two columns. Print EF of A is one column. EF of one A is one column. Covariance COV method. DF of B column. Execute this. It will give what is the covariance between these two columns. And if I want complete data frame covariance, see here, df dot covariance directly for the data frame. I can write like this, df dot covariance. It will give what is the covariance between A and A column, AB, AC, AD, AE, BA, BB, BC, BD, BE. Means for all the columns, what is the covariance? Like this, I can do correlation also. So what is the correlation between each columns, whether it is positively correlated or negatively correlated or strongly correlated, means how much dependency between one column to other column. By using, there is a method called as core method, CORR method, print df dot core method, so which will calculate correlation between different columns. Between different columns, it will calculate the correlation. And if I want only particular column correlation, the print df of A dot core of df of B. So which will calculate the correlation between those two columns. And now, as I told, if I see this data frame, if you see some A column, it is having some negative values, some positive values, something is there. Now, if I wanted to convert all these to positive values, so there is one method called as absolute method, the df of A. See here, if I execute this, all the positive values are converted to, all the negative values are converted to positive values. By using absolute method, it is possible to convert absolute values. And one more, to show this cumulative sum and cumulative product, I will use this one more data frame is there with me. So I'm having one data frame. See here. So this is my data frame. So print this data frame. Now I can apply. So df dot cums sum. What is cum sum is cumulative sum. What it will do, see the output previous data frame and this data frame. So first row is 5. So second row 5 plus 3 it is 8. And 8 plus 6 14. 14 plus 4 is 18. Like this second column 11. 11 plus 2 13. 13 plus 4 17. And 17 plus 3 is 20. Like this 4 plus 3 7. 7 plus 8 that is 4 plus 3 7, 7 plus 8 15, 15 plus 5 is 20. So last column 5 plus 4 it is 9, 9 plus 2 11, so 11 plus 8 is 19. And this is cumulative sum. Like this cumulative product, cum prod, so cumulative product. If you see here, first I need to take original data frame, then you can understand. So this is original data frame 5. So first row is 5. 5 into 3, 15. 15 into 6, 90. 90 into 4, 360. Means it will multiply, it will do the product between each other column, other row value. 5 into 3, 15. 15 into 6, 90. 90 into 4, 360. Like this 11 into 2, 22. 22 into 4, 88. 88 into last 3 is this value 264. Next, C column 4 into 3 12. So 3 into 8 24. So 3 into 8 24. 24 into 5 is 48. Like this cumulative sum and cumulative product we can do between the different columns and different rows. I can do row wise cumulative sum also. See here df dot cum sum of. Here, if I mention one, what it will do, row-wise sum, row-wise cumulative sum. See here, first row, 5 plus 11, 16, 11 plus 4, 20, 20 plus 5, 25. Like this, first 3 plus 2, 5, 5 plus 3, 8, 8 plus 4, 12. And like this, 6 plus 4, 10, 10 plus 8, 18, 18 plus 2, 20. So we can apply all these statistical methods, whatever we discussed: count, sum, mean, median, mode, standard deviation, product, cumulative sum, and cumulative product on the given data frame or series. Thank you, friends. In the next session, we will discuss other topics. In today's session, we are going to discuss about pandas working with text. What are the different functions available to work with the strings which are available in data frame or series? So these are the list of functions which are available in pandas to work with the text. That is lower function, which is used to convert the string to lowercase, and upper function, which is used to convert the string to uppercase, and the length, which will return the length of the string, and strip function, which is used to remove the spaces at front side and right side. So remove the spaces right and left side. So the strip function, if any string contains some spaces in the right side or left side, in both sides it will remove. And split function, which will remove the string, which will split the string, based on the separator mentioned. If no separator is mentioned, means by default it will take space. If I wanted to split the string with some other separator, then I need to mention that separator. And get dummies, it will return one heart encoded. It will show what it means, one heart encoded. Through an example, I will show you. One heart encoded variable means for each variable, it will create one binary variable. It will return whether that string is present in that variable with the one. If it is present, means it will return one. If it is not present, means it will return zero. And concatenate, so which is used to combine the strings with the specified separator. I have some multiple strings. If I wanted to combine those strings with some underscore or colon, I can specify that separator here, and contains whether specified pattern is present in the string or not. For example, if I mention the pattern is some ABC or GGG, so it will check whether this pattern is present in that string or not. Specified pattern present or not. And then replace function, which is used to replace A with B. So replacing old value with new value. And repeat function, which will repeat the string, with the specified value. If I mention there 2, it will repeat the string with 2 times. If I mention 4, it will repeat the string with 4 times. And count pattern to find the number of times that pattern is repeating. To count number of times that pattern is repeating, and starts with, ends with, which are used to check whether the string is starting with this pattern or ending with this pattern. And find, which is used to find whether the pattern is present or not. Here, if you see contains, it is used to check whether that string is present or not. And here it is used to find whether it is present in that string or not. So we will see practical what is the difference between contains and find. Find all means to find all the sub patterns in a given string. For example, if I am searching some ABC string, it will check wherever it is wherever it is there, it will return all the occurrences. Find means it will find only first occurrence. Swap case means to convert lower to upper, upper to lower to upper, or upper to lower case. And is lower, it will return true. If the string is lowercase, otherwise it will return false. And is upper, it will return true if the string is uppercase. And is numeric, it will return only if the string contains digits. Something if the string contains 1, 2, 3, so then it will return true. If the string contains some alphanumeric characters, then it will return false. Is numeric, which is used to check whether the given string contains only numeric values or not. All this we are going to see with an example. I will create some series or data frame. You will apply all these things on that series or data frame. Open the Jupyter notebook. Already I opened the Jupyter notebook. In order to work with these pandas, first import pandas pd. I will create one series. So we can use some numpy functions also. First import numpy as np. I will create a series s equal to pd dot series function to create the series. Something I am creating some set of strings. I can apply all those operations on these strings. I will apply all those operations on these strings. See here, something not a number, constant also I'm using. So now create a series. Print a series. See here, you can find all the strings which I have created. Now I apply all those operations for this series. The first operation, string dot lower, means first I will convert this string, this series to lower. So wherever s is my series, and in that for every string in this series, I need to convert it to lower. Convert the string to lower. See here, some first string, it is having some caps lock, but I'm converting it to complete lowercase let. Lowercase let. Now uppercase. Here in this case, not a number, it is a constant. It won't change this value because it is completely constant. That is predefined value. That is having some meaning. Not a number means it is, except it is not a value, means it is some empty value we can indicate by not a number in a data frame or series. That's why if you observe, you may have doubt why it is not changing, because it is a constant. It won't change this value. Now print start string dot upper to convert all the input to uppercase. See here, all the inputs are converted to uppercase. And find the string length by using length function. Here dot length function, which will returns how many characters. See, first string, it is having 5 characters, so it is returning 5. And second case, it will count the spaces also. If there is any space means it will take 1 character. So totally 21 characters. And in this case, 6 characters. And in this case, 6 characters. And this fourth case, it is not a number. Because it is completely constant, it won't return any length of its also. And 1, 2, 3, 4. And here, if you observe, I define it as a constant and not define it as a string. And one more note you can note down here is, it is not a number, means I'm not defining it as a string. So that's why it is a constant. It is not changing for this. Now length function. Next strip function, if any spaces, so those spaces will be removed. If any right side or front back side, if any spaces are there, it will remove those spaces. The strip function, which is used to remove all the spaces present in that strings. And split function, see here what this split function will do. Yes, that string dot split function. If I don't mention any input, means it will take by default space. If you see here, first case it is a single string. In the second case, it is having two strings. The agent equal to upcame. So it will divide this with a space. It will take this as one word, and this is another word. So that's why in the second input string you can find the two words. If I wanted to split by something, at the rate symbol, here in the split operation, I need to give at the rate symbol. So like that, based on my requirement, if I don't give anything, by default it will take space. And here see, I will use concatenate function. Yes, start string of cat where separator equal to underscore. What it will do means it will concatenate those strings with underscore. What it is doing is it is concatenating Akyam underscore Yagantishwarudu Akyam underscore Rakesh underscore Ramu at the rate G underscore. So this 1, 2, 3, 4. So it is not a string, that's why it is not appending to this. Just I have declared a constant, that's why it is not doing any operations on this value. The remaining all the strings are concatenated by using this underscore. Now, one more important function is get dummies. Get dummies, what it will do, I will take one more series. Maybe here we are confusing with NAN. I want to take this NAN here. See here, I will remove that. I will take the remaining values. So see here. So what this get dummies function will do? What this get dummies function will print. There are too many values also, it is difficult to understand what is it is doing. I will take only some three strings, execute this. Now my series contains three strings. Now I will apply get dummies function. Get dummies function. S dot str dot means series dot string dot get dummies. Get dummies function. Execute this. See here, for each input string, it will create a binary variable that is 0 or 1. First, if you see, first input string is Akyam. In the first case, first string, Akyam is there, so that is why it is written as 1. And remaining these are not there in the first case. That's why it is returning 0 and 0. The second case, in the second input string, Akyam is not there, means it is giving 0. Rakesh, it is not there, so it is giving 0. And Yaganti issued Akim, it is there, so that's why it is returning 1. The third case, the Rakesh, so here it is 0, Rakesh is available, it is giving 1, and it is giving 0. Basically, it is assigning, means arranging in alphabetical order A or Y from the given inputs. And what it is doing, it is taking each input string with a 0 or 1. If it is present means it will return 0, and if it is not present means, if it is present then it will return 1, if it is not present means it will return 0. This function we will use somewhere, means in neural networks. So later in encoders, there we will use this auto, means one hot encoding. So this concept we are going to call it as one hot encoding. One hot and And then there are other functions like contains function, find all functions. See here, s dot string dot contains function, something I am checking space. If you see here, what I am checking here, I am checking whether the string contains space. The first case, subkim, so there is no space, that's why it is giving false. The second case, there is a space in the string, that's why it is giving return true. And third case, there is no space in this string, so that's why it is returning false. This contains function will return either true or false. If this pattern is present means it will return true. If this pattern is not present means it will return false. Next, replace function, replace. For example, by mistake here I have given, so I will take again this one, so this string only. See here, I have this string, execute this. By mistake, I have given @ symbol in some multiple strings. I wanted to replace an @ symbol with dollar or underscore some other symbol. See here, print start str dot replace of symbol with dollar symbol. Symbol with dollar symbol. See here, got replaced with dollar symbol. Next, there is one more function called as repeat function. Print series dot string dot repeat of 2. First, to see the output, then you can easily understand what it is doing. It is repeating the string with specified number of times. If I mention 2 here, it is repeating the string with 2 times. If I mention 3, it will repeat the string with 3 times. It is repeating the string with 2 times or 3 times based on my requirement. I will repeat the string. Next function. The next function is count function. I wanted to count number of m's. The character m I wanted to find s dot string dot count of m. I wanted to find how many times m character is repeated. See here, because if my string series, if you see here, only one m, here also only one m. So there is no m here, there is no m here, so there is no m here. So again, execute this. See here, for example, I will change it to k. I wanted to find how many times k character is repeated. If you see, first case k 2 times, second string it is 2 times, third and fourth case it is no value, like that. The third case 1k is there, and fourth and fifth case there is no. That's why it is written 0 and 0. To find a specified sub pattern, we are going to check, means to find or to count number of times that sub pattern is repeated, we can use count function. Next starts with and ends with, which are used to check whether the string is starting with particular character or ending with particular character, a particular pattern. Starts with some character A, I'm checking. If you see here, no string is starting with, why it is giving? Actually, I'm checking small a. Here there are capital A's are there. So why this Python is completely case sensitive? Even it is an alphabet A, it will not recognize whether it is a small letter or capital letter. It will treat small letter is different from capital letter. That's why it is written true. I will try with capital letter. See here, yes. In the first case, first input string, it is starting with A. That's why it is giving. And similarly, I wanted to check ends with function. Ends with function to check whether the string is ending with particular character or not. Here the no string is ending with a, then what it will do? It will return false. And something I wanted to check which is ending. So whether the string is ending with small m. Yes. In first two cases, it is ending with small m. And find pattern. Find pattern. See here. Print s dot string dot find of. I wanted to find e. Find e. What it will do means it will return the index of that character. So this find function, which will return the index of that character. So this count function, which is returning the number of times that character is repeated and number of times that subpattern is repeated. And this starts with, which is used to check whether the string is starting or ending with that particular character as substring. Here I wanted to find how many times, means where is occurred. If you see here, our input string 0, 1, 2, 3 means it is occurred in this position. So where it is occurred 0, 1, 2, 3. So you can find, so where this E is occurred 0, 1, 2, 3. It is occurred at third position. And here you can see this is 0, 1, 2, 3, 4, 5, 6. So that's why it is showing sixth position E is started occurring. In the last two strings, there is no E. There is no E in these two last strings. So that's why it is returning -1. If the string is not found means this find method, it will return -1. And find all, which is used to find all the occurrences of E. For example, instead of find, if I use find all method, this find all method which will return wherever the E is occurring, all the places it will return. So how many times that E is occurring, all those places it will, means all those number of occurrences it will return. You see here, there are three E's are there. That's why it is returning find all. It is returning all the three places. So this final function basically it will return how many times, means where and all it is occurred that. Now swap case function print string s dot str dot swap case. It will convert lower to upper, upper to lower. If you see here, my input first character is capital, but remaining characters are small. But if I use swap case, it will convert lower to upper, upper to lower. And I wanted to check whether it contains lower cases. Print string dot str dot lower. If it is completely lowercase, then only it will returns true. Means not lower. To check whether is it lower or not, I need to use is lower. Just if I use lower function means which will convert all the strings to lowercase. I wanted to check whether it is lowercase or not. Means all are contents not, means if you see the input here, something contains capital letters, something contains capital letters B, because that's why it is returning false. Whether all the characters are lower, then only it will return true. And similarly, we can use upper function, is upper function, which is used to check whether all the characters are upper. And finally, we can use numeric, use numeric. If you see here, the last case only is numeric because in the last string only it contains only number. Is numeric, which is used to check whether the string contains only numeric characters or not. So these are the different functions which are available in Pandas to work with. Is numeric, is upper, is lower, swap case. Only some different function we are getting here is get dummies. Get dummies, for each string it will create one binary variable whether it is there or not, 0 or 1. For each string, it will check whether that the get done means it will return binary value. Means if it is present means it will return 1. If it is not present means it will return 0. First, it will place all those strings like this. So first, it will place all those strings in alphabetical order. Alphabetical order. Akim, Rakesh, and Yagantishwar Akim. It will check whether it is present or not in this row. If it is present means it will return 1, otherwise it will return 0. So these are the some important functions which are available in Pandas to work with the text friends. In the next class we will meet with the. Hi friends, in today's session we are going to discuss about data munging. What is data munging? So how to do the data munging in the data sets. The data munging is nothing but you can convert in data munging. Data munging. You are going to convert a particular data into different format. Different format. For example, my data in a CSV file, I wanted to convert into HTML file, or I wanted to convert into some Excel file, or I wanted to convert into some other format. So one file format to another file format we can convert. So that process we are going to call it as a data munging. So we can convert that CSV file into HTML file or Excel file or other format. So that process we are going to call it as data munging. So in order to do this, so first I will open Jupyter Notebook. So already open Jupyter Notebook. In order to use Pandas, first import Pandas as PD. Once if we import, I can read the CSV file. I have one CSV file. So in my file path, so diabetes India, this is a CSV file. In this CSV file, it is having patient's info like glucose, blood pressure, skin thickness. Now it is a CSV file. If I open and check this CSV file, open it with notepad, you can see each value is separated with comma. Now I am going to convert this CSV file into HTML file. See here. First read this CSV file. If you read the CSV file, it will construct a data frame pd.read underscore CSV to read the CSV file. In my case, the file is stored at this path. See here. So this is my file path. And I need to mention the file with extension also because I'm reading CSV file. See here. .csv. It will create a CSV data frame. Now, if I read that file, it will create a data frame. Now, I wanted to convert this data frame into HTML file. See here, df dot. There is a function on data frame to HTML. To HTML. Something I am converting. For example, this is diabetes.html. Diabetes.html. What it will convert means it will create an HTML code. It will convert this as a HTML table. See here, if I give the full path like something C drive and the files and then diabetes.html, it will create this file in this path. If I don't give any path, it will create this file in working directory. So shift enter. So go to that current folder. I am working in Pandas examples. Here if you see diabetes, it is a HTML file. See here it is a HTML file. Open this diabetes HTML. Now it is created HTML code. So if you right click this and check this code, automatically it is created. So this HTML table, body, so everything it is created, required code, HTML head, body and table, border is this, table head, table body. So everything automatically it is generating HTML code. The process of converting one format to another format, we can call it as a data munging. Data munging is nothing but converting one format file to another file format. So that may be HTML or Excel, CSV file, or any other format. So that concept we are going to call it as data munging. So thank you, friends. So we'll stop the session.